Relatively speaking. First day after the weekend. Relatively speaking. First day after the weekend. Mickelson Morley. It showed that the earth, they don't move, huh? What they do, shorten the length of the ruler. Hey, that's just how they fooled ya. Tune in Wednesdays, bet that we gon' school ya. Mickelson Morley, it showed no displacement. Nicholson, Gale, Pearson, it measured rotation. Let's break it down in layman. That means the earth is stationed. No planets and spaceships, they're all animations. Relatively speaking. First day after the weekend. Relatively speaking. First day after the weekend.
Warning. The following contains scenes that globularists may find disturbing. If you are suffering from cognitive dissonance, you may experience violent, degenerate, and erratic behavior. Viewer discretion is advised.
In a world. Hopefully everything sounds good. How's it? So, welcome to Relatively Speaking, 8 Hubble Crisis. Hard to pick from the crisis. Modern cosmology. Crisis. You guys can hear me, I think. Let's figure it out. Whoa, that's worse to me. What was that? Oh, I sound. In a world. Yeah, I don't know. In a world. That's probably louder. There we go. No sound. See, everyone's saying different stuff. There's no sound. Oh, it's so good. Oh, there's no sound. Oh. It's really frustrating. All right, cool. Sorry. All right. Anyway, welcome to Relatively Speaking, episode 8 about the Hubble crisis. I was just saying it's difficult to pick a crisis nowadays because there's so many of them. But I do think it's beneficial just to hear it from coming outside of the, or coming within their official paradigm of this heliocentric model. So we can skip over all the nuh-uh. All right, so we're going to play a quick little video to give you an idea of what's going on here.
So the Hubble tension refers to the idea that you can measure the local expansion rate of the universe, which we call the Hubble constant, after the person who discovered that the universe was expanding. And we can also predict what the local expansion rate should be today by measuring data from the very early universe, fitting a cosmological model to that, and extrapolating that forward in time to the present day. So we have one prediction from fitting to the early universe, and we have one local measurement. And if our understanding of the cosmological model is correct, those two measurements, the measurement that was a prediction and the measurement that was actually a local measurement, they should agree. And they don't. And we call that the Hubble tension. And if it doesn't turn out...
Yo, Google be hating.
And they don't. And we call that the Hubble tension. And if it doesn't turn out that this is due to simply some misunderstanding about this very complicated data, it could signal that we have a missing ingredient in our knowledge of the cosmological model. There are possible hypotheses for what that extra ingredient could be, but none of them are really that compelling. So it is a basic, like, here be dragons kind of situation. It's not a dead end. It's actually signaling that there is a mystery to be solved here. And the mystery is that these two data sets must somehow agree, or else...
Yeah, because it's obviously not even an option to challenge the religion. It's just a mystery. One thing we know for sure, there's no way the model's wrong, right? That would be heretical.
Else, we must fit something else into the cosmological model. And that mystery is driving actually new ways of measuring this Hubble tension and new local ways of measuring the Hubble constant in the first place. For example, by studying the mergers of gravitational wave sources. And that can reveal whether either or both of those previous measurements were correct or not. And maybe give a third measurement to be an arbiter among them.
So there you go. Professor of Astrophysics, University College of London. And they said we needed to look at the we need to look at the gravitational waves. Oh, specifically the source of the gravitational waves. Let me let you guys in on a little secret, okay? You cannot trust these pop-sci articles. They lie. They just want you to click on it and read it. They want the layman to be like, oh my gosh. Here's the reality of the situation. When they claim that they detect an interference pattern equivalent to 1/10,000th the width of a proton. That's right, soak it in. Soak it in. Yeah. You know, protons, really tiny little components of an atom, which we'll be doing at Ether Stream soon to bury all that. Redo my presentation. People keep asking. Okay. They claim that they have basically a big Michelson-Gell-Pearson, just a giant laser. And they use interferometry. It's where lasers cross paths and you get an interference pattern, right? And it is a very precise way to measure. They claim that they detected a gravitational wave causing a displacement equivalent to the width of 1/10,000th of a proton. You aren't on Rokfin, right? I'm on Rokfin. So, yeah, and by the way, the last stream we did, Digital Order, got struck midstream. They gave me a strike, said I couldn't stream for a week. I appealed it. I won the appeal. Got put back up there. Got taken back down, but without a strike. So, that's where we're at. So if you want to watch the Digital Order stream, it's on Rokfin. All right. Stop the sign language, please. Go somewhere else. Oh, Austin moves his hand when he talks. Go somewhere else, bro. What do you think this is? Stop talking with your hands. I hate hand gestures. Stop the sign language, please. Leave. You could just leave. Okay. And I remember your name. You're on thin ice, buddy. All right. So anyway, now they say that they don't really know where these gravitational waves come from or how far away they are, what direction they come from. They just kind of speculate and guess. And they claim it comes from like billions and billions and billions of miles away. That's right. They claim that a gravitational wave from many, many billions of miles away, maybe more than that, honestly. I mean, they claim that, so it is actually more than that, yeah, because it's like many, many light years. That it causes interference appearance 1/10,000th the width of a proton. So anyway, this whole like LIGO, they detect gravitational waves is laughably stupid. They absolutely do not do that. 100% don't do that. It's not even in the ballpark of an actual thing. They don't actually detect gravitational waves. It's 100% pseudoscience. But anyway, so this lady here, she really sugarcoats the situation. Oh, it just means there's a mystery. Oh, blah, 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 blah. Okay, so I have another video for you. But wait, actually, let me kind of tell you what it is so you guys have an idea of what's going on here. So you have the Hubble constant and you have the cosmological constant. Okay? And so the cosmological constant was introduced by Albert Einstein in his little goofy general relativity field equations. And it's basically, that's how they interpret it now. Now, he called it his biggest blunder, right? But then it had to be reintroduced because of discrepancies in the model with how fast the universe is expanding. They claim it's going a minimum of 4 times faster than the speed of light, expanding in all directions from a singularity, but there's no center. So you figure that one out. Anyway, that's the energy needed is the cosmological constant, and the rate at which the universe expands is the Hubble constant. There's something called the Hubble tension. Hubble tension. That is the discrepancy between these two numbers, and more specifically, when they, it's not, let me take that back. I don't want you to get confused. That's not technically what it is. What it is they look out and they see that on the local scale, right, then the value of this expansion does not match further away. Okay? And there's a big, if you look at my conversation I had with Professor Parks, I touch on this. And he's like, yeah, I'm not going to lie with it. We have a problem. We don't know how to figure it out. We don't know it. It may just be an instrumental error. So this is their excuse for everything, right? When the data doesn't match what they want it to say, they say it must be an error in the data. They did this with the cosmic microwave background again and again and again and again. And it just keeps showing the data. So they just keep saying there still must be something wrong with the instruments. Instrumental error. But then they will claim to do stuff like know that the universe's visible edge is 46 billion light years away. Tell you that 1 teaspoon of a neutron star weighs hundreds of millions of tons, 10 million tons or hundreds of millions of tons, something insane. Right? Their instruments are good enough to do that. They're good enough to detect alleged parallax whenever they can't even resolve beneath a degree and it's just a wiggling little star. And sometimes it's negative. They can make all these ridiculous claims, and as long as it fits within their paradigm, it's fine. But when it doesn't, it's instrumental error, which is hilarious. They're just looking out at the sky, and if it's actually expanding, then based on what they see, it should be expanding at a certain rate. And the rates don't match. They should match. It's just consistent accelerative expansion in all directions, but they don't match, and it's not even close. Not even close. They try to fudge, what they originally did was try to fudge the error bar for the instruments used for the more local and then the more distant measurements. And they fudge the error bars, and it still doesn't work. It still doesn't work. Okay. So I'm going to let this guy explain it. Long story short, there's a discrepancy in how fast the universe is allegedly expanding on the local scale and further away, which means it doesn't work with the claim that the universe is expanding away from us. It doesn't work. It can't be different. It can't be physically. It's supposedly expanding in all directions. Okay. So again, you have the cosmological constant, which is the energy that is needed and missing, by the way, to expand the universe, which is called the Hubble constant. Okay, so expansion, Hubble constant, energy that caused the expansion, cosmological constant. Now these are tied together. It doesn't match. So even the energy they need to make it expand doesn't match. You guys have heard that, where people come up with numbers like 10 to the 120th power. Michio Kaku famously said that. He's not the only one that said that. Of course, they looked at the energy in a vacuum, and they're like, maybe this is what's there, this background quantum vacuum energy. Maybe this is what's the energy expanding everything, but it doesn't work at all. The numbers don't match it. They're off by 10 to the 120th power. Some people say, well, there's not really that big of a discrepancy. We disagree with how they got their numbers, and they're just assuming that it's the quantum energy. They're not just assuming it. It's the only thing they can even bring evidence forth to explain what other energy would be in the vacuum. But it doesn't work. It's way too much energy. Doesn't work. So there's your problem with the cosmological constant, right? So just to make sure everyone understands the basic things here, the cosmological constant, the amount of energy needed to expand this universe allegedly at least 4 times faster than the speed of light. They don't have that energy. They call it dark energy. Okay? And they say, well, Einstein's field equations allow for it. He predicted it, and he called it his biggest blunder. They're like, but it still works, so it doesn't debunk relativity. Well, he said it doesn't work within his thing. You could say he was wrong. Okay, so, but they don't know what it is. They can't explain it. They can't use the vacuum energy you actually do find, like on the Earth in a vacuum chamber, right? Because it doesn't match. Not even close. It's not even in the ballpark of matching. So they're stuck. Okay, they have a dark energy crisis. That's the cosmological constant, the energy needed to cause this alleged expansion of the universe. It doesn't work. Now you have the Hubble constant. This is the rate at which the universe expands. Now, this is famously attributed to Edwin Hubble. Edwin Hubble made incredibly important and pivotal discoveries, observations that showed that the current model didn't work. Course, and if you know that in like 1925 he saw distant galaxies move in relation to the Earth, he's like, what's going on? This shouldn't be the case. And then they came up with the idea, the analogy of like a balloon blowing up, and every point on the balloon is going to look out and feel like they're in the center, or raisins in a loaf of bread. So heliocentric model, we're tucked away in a little dark, insignificant corner of the universe. We're tiny, insignificant, completely random, have no special or unique position. The universe is going crazy, doesn't care about us. When we look out, we're going to see all kinds of random movement, blue shift, red shift, everything moving, just completely not caring about us. We're tucked away in the corner where it doesn't even matter. Geocentric model. Everything's going to move in relation to the Earth in every direction that we look, because the Earth is in the center of the universe. I prefer the word cosmos because it means order. What did they see? Everything, including the distant galaxies, move in relation to the Earth. Everything moves relative to the Earth, like it's in the center. What did they do? Did they throw out the heliocentric model? Of course not. Did they consider the geocentric model, which predicted this? Of course not. They changed the heliocentric model to say, sure, our new model is going to say, it is going to look like we're in the center. It's going to look exactly like what a geocentric model would predict, but it's just an illusion. And every single place you look in the universe would look like that. And fortunately for us, we can't test that. We have to get far outside of our own galaxy to even begin to try to see if that's the case. So unfalsifiable, fix, hijacking the geocentric position, as the geocentric position just sits here unscathed, unwavering, and never has to change. Same with the cosmic microwave background. Okay, that's Edwin Hubble, 1925. He famously said, if we're wrong about our interpretation of redshift, the universe could be, or would be, more local, more dense, finite, and suspiciously young. Okay. Now, move forward. So now you got the background of the Hubble tension. of the Hubble constant and the cosmological constant. One more time. Cosmological constant, the energy required to expand the universe. The Hubble constant, the rate at which that expansion occurs. There's a discrepancy between these two, and there's a discrepancy between the rate at which this supposed expansion has happened based on their own model. They look out and the data doesn't work. The local rate of expansion that they quote unquote measure doesn't match the further out observations, but they should be the same. They should be the same because it's supposedly just the universe expanding everywhere. And it's drastically off, by the way. Megaparsecs, which is a huge unit. Okay, so let's watch some more of this video and we'll get more into it.
What if we were to tell you that scientists have absolutely no idea how old the universe is? That might be a bit sensationalist, as we do have some idea, but we don't know for sure. And more importantly, we don't know why we don't know. The first reasonably accurate calculation for the age of the universe came in 1958 from astronomer Alan Sandage, derived from measuring the universe's rate of expansion. There was a margin of error, but it was calculated that the universe was roughly 14.5 billion years old, give or take a billion years, with scientists believing that the best estimate is 13.8 billion years. For nearly 50 years, this age of the universe was accepted. As science improved, so too did our calculations, and that margin of error became smaller and smaller. Then, in the year 2000, a new method for measuring the rate of expansion of the universe was created. At first, this was great. Because of the margin of error, both methods offered a possible range for the age of the universe, and those ranges, they overlapped. But as the years went on and our measurements became more precise, those ranges shrank in opposite directions, resulting in two different answers. The discrepancy in the two different calculations is known as the Hubble tension. And it's getting worse. Recent data from the Planck Observatory has only further widened the gap between the two values. This means one of two things. Either the maths that has been double-checked in...
Now, to go ahead and get out in front of this, right? In my opinion, they are making observations of the sky, and they make them from high above the Earth. They're just not going all the way out into outer space, millions and millions and millions of miles away. That's pseudoscience. In my opinion, that's just a made-up, ridiculous claim that can't be verified in any way. And what they claim space is physically impossible. But if you've ever looked into Sophia, for example, you can make crazy observations just 40,000 feet up. Imagine if you went 100,000 feet up, which is where they went to get cosmic microwave background results on high altitude balloons. They gather that information. Now put a really, really good telescope up very high in the air. You can see into the sky. Okay. So put aside like the claim of where they say this stuff went. It doesn't matter. It doesn't matter. You can look into the sky and you can see certain things, and you can see it doesn't match what they claim the sky is. Now, this is specifically about heliocentrism and geocentrism. It's relatively speaking, right? So everyone pump the brakes. It's okay. All right, let's move on. I just wanted to get out in front of that. I know that's what people were thinking.
Innumerable times is somehow wrong, or our current understanding of physics is even more incomplete than we realized, and there's new physics out there for us to learn.
Or maybe your model's just wrong. Just say that.
To determine the age of the universe, we need to calculate the Hubble
This is important.
constant. This is the unit of measurements that describes the expansion of the universe, written in kilometers per second per megaparsec. And we promise that all of this sounds more complicated than it actually is. You'll get there. Basically, if we can measure how far away a star is and how fast it's moving, we can figure out how long it took to get there. If you knew a car was traveling away from you at 60 miles per hour and was 60 miles away, then you know that it's been traveling for an hour. What we're doing with the stars is basically the same calculation, just on a really much bigger scale. Oh, and also the maths is made more complicated because of how the universe expands. The Hubble constant is expressed in kilometers per...
I want to give you an idea of like what they're saying. I guess I just realized, people don't really know, so. A megaparsec is like 3 million light years. So a parsec is like just over 3 light years. Megaparsec, of course, is 1 million parsecs. So a megaparsec is just over 3 million light years. So just really take that in here. A light year is supposedly 5.88 trillion miles. And we're talking about 3.26, I think, million light years for a megaparsec. Their discrepancy is like over 5 parsecs. Okay, so I just want you guys to kind of understand the lingo a little bit. Let's go.
Per second per megaparsec, because the expansion of the universe is actually accelerating. So the further away from us something is, the faster away from us it is traveling. This is all well and good, but how do we actually measure how far these objects are away from us? Now, this is where we get the distance ladder, a series of observations and calculations that builds upon one another to measure distances further and further away. First, we begin with the local universe. Local, in this instance, referring to objects within the Milky Way. Now, if you hold your finger in front of your face and then close one eye and then open the other eye and close the other one, you'll notice that your finger moves from side to side relative to the background behind it. The closer your finger is to your face, the more this is going to switch when you move from one eye to another. This observed displacement of an object against a background is called parallax, and it happens because your two eyes are in different physical locations. Because the shift is greater the closer an object is, we can use this same principle to measure the distance from Earth to objects within the Milky Way, which is super cool. All you need to do is replace your finger in our demonstration with some distant star and replace your eyes with the view from Earth at opposite ends of its orbit around.
What they're not going to tell you is that rarely do they get the measurements that they expect or that the model predicts. They take averages, they fluctuate it, they introduce error bars, it goes negative, they treat it as positive or disregard it. It's not consistently what it's supposed to be relative to what they claim the distances are or the surrounding distances are. And they actually use all kinds of back in the questions and reifications for different ways to determine distance, throw it on top of it, and then just go crazy claiming that parallax is actually legitimately measured when actually they just cook the books on an egregious level. That's what actually happens.
The sun, a distance of approximately 300 million kilometers. By measuring the shift from those two locations, we can calculate how far away it is. Because the parallax of an object gets smaller the further away it is, to the point of being imperceptible even with advanced technology, a new system needed to be designed to measure the distance of objects even further away from our galaxy. This brings us
Okay, now keep in mind, like, there's a telescope on the ground, bro. So just throw something on a balloon. Yeah, it's on a mountain, whatever. Throw some stuff up high in the sky. You're going to get probably pretty insane shots of the sky.
Needed to be designed to measure the distance of objects even further away from our galaxy. This brings us to a special type of star known as a Cepheid variable. Cepheids are a type of bright pulsating star, and in 1908, American astronomer Henrietta Leavitt discovered a direct correlation between how bright a Cepheid was and how fast it was pulsating. Because these two values were directly proportional, we could measure the apparent brightness and the pulsation period of a Cepheid that was tens of billions of light years away.
But no, they couldn't, though. They assumed the medium that's impossible, but it does, of course, make sense that the pulsing light will be relative to its brightness. Duh. But you need to know what's going on with the medium. Just like Edwin Hubble himself said, looks like it could be more dense and much more local.
Cepheid's period would tell us what the star's actual brightness was, and its distance could be determined by comparing that to the apparent brightness. This made Cepheids invaluable for their use as standard candles. Stars come in all different shapes, sizes, and brightnesses, but a standard candle is an object whose luminosity is always known, in this case as a function of its pulsation period. There was just...
People are like, you just do this for money. Look at this, dude. Look at this. Over 500,000 views in 4 months. He sits here and reads a script for 12 minutes, crosses his leg, stresses on Metro, boom. Gets promoted by algorithms and gets tons of ad revenue. So, I think we don't do this for money, maybe.
one other step before scientists could begin using these candles to measure even greater distances across the universe. First, they had to use parallax to measure the distance of Cepheids within the Milky Way. The relationship between the period and brightness of a Cepheid was known, but they needed the parallax measurements of nearby Cepheids to create a numerical base that they could then use and extend over greater distances. Unfortunately,
I need everyone to realize the reason this is important is because all of their pseudoscientific reification fallacies stacked on top of each other has cornered them into a very specific, confined interpretation of the stuff that they see. They cannot just pull the rug out from underneath themselves, because then all their distances, all their brightness, everything implodes in on itself. So they have confined themselves within pseudoscientific barriers. Okay. And then we are about to find out that has caused them to not be able to explain even the possibility of their model.
Unfortunately, Cepheids become too faint for us to see after about 100 million light years. Now that may seem really far, but it's only about 0.1% of the width of the universe. So we're going to need another technique. And this brings us to the final rung on our ladder, Type 1a supernovas. A Type 1a supernova occurs in binary star systems where at least one of the two stars is a white dwarf. Because there is a fixed critical mass at which a white dwarf will go supernova, all Type 1a supernovas should have the same peak level of brightness. The problem is that while we know this is true, we haven't seen one of these supernovas up close, so we don't have any way to know what that peak brightness level actually was.
So even though we know this is true, we've never actually seen it.
To solve this problem, we needed to find galaxies in which a 1a supernova went off that also contained Cepheids. Using the previous method, we could calculate the distance to that galaxy using the Cepheids. Once we know how far away that galaxy was, we could also use the distance and the apparent luminosity of the supernova to determine the actual luminosity of the supernova.
Please tell me you're keeping up with the amount of reification fallacies. It's like insane.
With that value in hand, we could then locate 1a supernovas that occurred in galaxies much further away than we could see Cepheids, and use the apparent brightness and actual brightness to calculate the distance away. Because these supernovas are so massively bright, this allowed us to measure distances up to 1 billion light years away. The first real consensus reached using this
This dude says this stuff so seriously. I think the reason people fall for this is because they don't understand it. They're like, so smarter people than me had to do it. That's literally it. That's what it is. It's so convoluted and drowning in theoretical calculative assumption. People are like, I'm out of here. Like, you got it. You must know more than me.
That came in 2001 when the Hubble constant was measured at 72 plus or minus 8. Our measurements have become much more precise over the past 2 decades, and the most recent calculations using a distance ladder in February of 2022 gave a constant of 73.4 plus or minus about 1. This is a much smaller range, and well, therein lies the problem. The cosmic microwave background is the first light created in the universe, originating from when the universe was only 370,000 years old. Before this, the universe was too hot for atoms to form, leaving it essentially opaque. When the temperature cooled enough for the first hydrogen and helium atoms to form, the universe became transparent and light could be emitted. The CMB is only detectable in long radio wavelengths of light that reach us from every direction. The temperature of the universe at the time this light was first emitted was imprinted on the CMB, and at first it looked like it was completely uniform with a temperature of just under 3 Kelvin. Now that we have much more sophisticated equipment, we see that the CMB actually looks more like this. The darker blue images on this image represent the coldest temperatures, while the red represents the hottest temperatures. Those colder regions show the areas that would have a high enough density of the newly formed atoms to build the first stars. Essentially,
so the cosmic microwave background has come back to bite them once again. Okay. And they have these 2 different methods that they use, which is the cosmic distance ladder method, which we just covered with all these pseudoscientific assumptions. But mind you, this one is very important. Let me come over here and make sure you guys get it, because it's easy to get lost in the pseudoscience. Okay. They have the cosmic ladder method, right? So this is built, like we just heard him explain, on all kinds of very crucial and pivotal measurement methods, as they would call it. It's calculative assumptions in pseudoscience, and how they determined so much about this alleged model. Okay, so they can't just get rid of that thing. it makes the whole model implode. They now can't make any fairy tale stories up about the distances and the sizes and all this. Like, they're in trouble if they have to get rid of this ladder method. It's comprised of core tenets to their made-up model. They then go look at the cosmic microwave background, which again, you can get this in a balloon. Once again, just like we covered last week, it drops the axe on the heliocentric model. It doesn't work. It doesn't work. And so I think he may say the number. We'll cover the number in a second. I want to make sure everyone understands what I'm saying. So when we say there's a difference in the local quote unquote measurements and the distant ones, it's that the cosmic microwave background is more of a local. We're looking out and we're able to more intricately determine things on the local scale. You compare these two things, right? And the numbers don't match. But they should match because they're supposedly measuring the same thing, which is the Hubble constant, the rate at which the universe is supposedly expanding. They've used two different methods. These methods have to coincide with each other if all their other claims are true. They don't match. This is called the Hubble tension. Okay. But I'll let him finish and we'll get more into it. Then we'll open up the phone lines.
The CMB is a 13.7 billion-year-old blueprint for the construction of the entire universe. To give you an idea of just how incredible it is that we can even detect and decipher this blueprint, the difference in temperature between the coldest and hottest points in the CMB is only 200 microkelvin, or 0.0002 degrees Celsius. It was also discovered entirely by accident. Everything within this blueprint can be described using 6 parameters: the ratios of matter, and dark energy, the shape and structure of the universe, and the rate of expansion of the universe. When we compared the CMB to our best model of the universe, the data lines up almost perfectly. Since we already have values for 5 of the 6 parameters, we can use all of this to calculate a value for the rate of expansion of the universe, the Hubble constant. While measurements using the distance ladder date back to the 1950s, using CMB to calculate the Hubble constant is a much newer method. The first such calculations came in 2003 using data from the then new Wilkinson microwave anisotropy probe. They measured
Which, by the way, again, their model claims that it should be isotropic, like we explain later. So I just want to make sure that no one leaves confused. So they use a ladder method. And what they do is they come up with all these ideas of like brightness, pulsation and brightness relationship, parallax. And they come up with these distances. And they come up with baselines with different distances to then extend it out and to supposedly get other distances to things further away. It's a more localized thing, actually. The latter method is the more localized. The cosmic microwave claims to look way back in time. It's like the Big Bang scan, right? And when they compare the values of the expansion from these two methods, they don't match. It's like, must be wrong. Let's do it again. Still don't match. Still don't match. Still don't match. Still don't match. They never match, but they consistently show the same values. So it's not like they get a value that's like 80 and then 60 and then 50 and then 70. It's consistently like 68, 73. Consistently. Now with the CMB, what they did was, must be a problem with the data. The instruments must be wrong. Never mind. Still must be wrong. Like over and over, and they kept getting the same results. But it doesn't work with their model, so the data must be wrong. They do the same thing with this. They said the instruments must be wrong. One of these methods are wrong. And they always want to throw the CMB under the bus. But what's funny is you'll hear people running around claiming the CMB proves the Big Bang. This is the problem. We live in an era of propaganda, so people read pop sci articles and think if they come regurgitate some of the basic stuff they retained within the popular science mainstream propaganda that they know what's going on. But they lie. They blatantly lie, and they misrepresent the accuracy. Okay, let's finish. There's only a few more minutes left.
the Hubble constant at 72 plus or minus 5, perfectly in line with contemporary values given from the distance ladder. A few years later, the Planck Space Observatory was launched to take measurements of the CMB with a much higher degree of sensitivity. Planck was decommissioned in October 2013, but it wasn't until 2018 that the final results from the team were published. That result was a Hubble constant of 67.6 plus or minus 0.4. This no longer matched the distance ladder's newer result of 73.4, and that discrepancy, the Hubble tension, is highly statistically significant. Alright, we've laid it all out, so what does it actually mean? Because of the Hubble tension, the age of the universe is uncertain. The ages calculated by those two values differ by about 1 billion years, which is over 7% the entire age of the universe.
Oh, this isn't a big deal. Oh.
The age of the universe is uncertain. The ages calculated by those two values differ by about 1 billion years, which is over 7% the entire age of the universe. You just said you don't know the age of the universe, and then you said this is 7% of the age. Really don't know what's causing it. The first possibility is that something within the distance ladder is incorrect. Since each step builds upon the previous one, any mistake would then propagate through the rest of the results. Even if our I haven't even watched all this. Even he is telling you what I just told you. Because it's just common sense. If you paid attention during the ladder section, it's comprised of all these core tenets of their story. You got a real problem if that method isn't correct. Now, this is a religion, so we have to hold on to it no matter what. Dark flow, dark energy, dark fairies, dark Superman, dark whatever we can come up with. Anything in the world other than scrapping the model. Anything. Over 7% the entire age of the universe. And we really don't know what's causing it. The first possibility is that something within the distance ladder is incorrect. Since each step builds upon the previous one, any mistake would then propagate through the rest of the results. Even if which would literally end the entire cosmological model as they know it. Calculations involving Cepheids and type 1a supernovas are correct, if the initial measurements using parallax were wrong, it would cause everything else to be wrong as well. This means that if there is a problem with the ladder, there's no way to easily determine where the mistake lies, and every part of it needs to be measured and calculated over and over again. It could also be that the problem isn't... Yeah, because you shouldn't have done that already. Right. And none of it's measured. It's calculative assumption. With the calculations themselves, but something about the method itself is fundamentally wrong. The much more exciting possibility is that the calculations using CMB are wrong. That would mean that something about... He said the exciting possibility. He just gave it away. This dude's also religious. The exciting possibility is that the CMB is wrong. Exciting because we get to keep all our pseudoscientific fairy tales built upon presumptuous calculations, reifying our model. The more exciting possibility, buddy, you realize that they took some of the results from the CMB and they called it evil? How is this not a religion at this point? How does someone watch this show and not realize this is a religion? It's a belief system built upon the doctrine of men despite contrary evidence for acquiring blind faith. It is a religion. Dude, in quote-unquote science, because this is not science, this is not natural science, it's observational guesswork about the sky, you don't call something evil. You don't just say, that doesn't work with my fairy tale, the instruments must be wrong. The more exciting possibility is that we get to hold on to all our pseudoscience. That's the more exciting possibility. Like, what? It's a religion, bro. It's really weird. You should not hand over your thinking to these people. This show's objective is to pull back the curtain so you see what's really behind there. It is not what the mainstream propaganda tries to tell you. Also not what insecure people yell from behind their keyboard either. Our best current model of the universe is either incorrect or incomplete. There are a lot of theories being thrown around about... They always do that too. They throw in the or incomplete. They've done this with relativity since the 30s. It's wrong. They say, oh, well, just relativity is just incomplete. Oh, no, it's wrong. It's wrong.
Okay. 83% of the matter in the universe in your model is not accounted for. Relativistic prediction doesn't work. Oh, it's just incomplete. No, it's wrong. You can't add anything of substance to the background. According to relativity, it's only space and time. It's wrong. Oh, no, it's just incomplete. No, it's wrong. If you had to revise it, that means you would have to completely do away with that one and add things that were previously asserted to not be true. That means it's wrong. I just think it's so wild.
What could be causing this difference, but thus far, nothing has been tested. Currently, it seems more likely that the issue lies with the distance ladder, specifically with the Cepheid variables. It was speculated that the Cepheid measurement system was biased bright, meaning that we are measuring them as being brighter than they actually are. Because we can only take images with limited resolution at massive distances, it's possible the light from a Cepheid and another nearby star were essentially overlapping, making it look like a single...
They get to just make stuff up. It's possible that they were just overlapping. Now, what's so funny is they would have never told you that the Cepheid variables were potentially just wrong until they were forced to. In fact, they would have told you, we know exactly how far things are based on the pulsation and based on how bright they are. We know exactly how far stuff is. Give or take a little bit, there's a little bit of error, like maybe 1-2%, but we know how far everything, oh, looks like it may be wrong.
Star with a higher apparent brightness than it should have. This theory was proposed when scientists decided to try to use red giant stars as standard candles instead of Cepheids for the second rung of the distance ladder. Using this method, they calculated a value for the Hubble constant that was no longer significantly different from the one found using the CMB. Our understanding of the universe...
So what he's saying is they completely changed everything to try to make the difference a little bit less, but it still didn't work. He says it's not much different. Yes, it still didn't match. Even when you completely change a fundamental component of your distant claims. If that ladder starts to crumble, it all falls down.
Is constantly improving. But as we learn more, we often find things that we previously believed to be true are actually wrong. It was previously believed that Earth was the center of the solar system and the Milky
It's so funny. They always do stuff like this.
Way galaxy was the entire universe. Even the idea that Earth could be millions or even billions of years old is relatively new. These discoveries are exciting because they give us greater knowledge about the universe. If it turns out that our distance ladder was incorrect, we'll probably know very soon. One of the missions for the James Webb Space Telescope's first year is to examine Cepheids that were previously imaged by the Hubble telescope. Because of the incredible increase in resolution provided by James Webb, we should be able to determine whether the Cepheids were really biased bright or if the cause of the Hubble tension lies somewhere else. There is already some preliminary data from James Webb that has been used to check this hypothesis. While the initial results don't show any difference from the measurements taken using Hubble, the data being collected was calibrated for an unrelated mission, and so it's not necessarily indicative of what the final determination will be.
Okay, yeah, there you go. Oh, we've heard enough. Okay, so now you guys maybe have put together what we're about to discuss, and then we're going to open up the phone lines, and I want to hear someone explain to me how this isn't a problem for your model. But what's going to happen is someone comes to play, that's how science works. It's just we're learning new things. It's exciting mysteries and discoveries. Like you just said about anything that refutes the model, and then somehow it goes away. Okay. Now, James Webb, who knows what it really is? Probably just something on a platform that's high in the sky. It has better resolution than some of the images they showed us, and then they color correct them. I think they are definitely taking pictures of the sky. I don't buy the whole like, oh, it's all fake. No, it's just lied about and misinterpreted by the people that get the result. That guy looks like my ex-husband. So, check this out. There's a prediction. Well, more so, there's the two different methods, okay? One of them is the ladder method. It's comprised of all kinds of different subcomponents that have been pivotal core tenets of the current model, how they get distances, all kinds of stuff, okay? And they go measure the rate at which the universe is expanding. Now, he tries to say, we just don't know how old the universe is, because when you paint it that way, it's like, oh, well, you're trying to figure out something so crazy like how old this universe that's billions of years old is. Of course, we don't fully understand it yet. No, you're claiming that the universe is expanding, okay, in all directions to explain away the evidence that we are clearly in the center. That's what it actually is. Now you look out, you made up all these fairy tales with your ladder method. You use that method to try to determine, based on all your other interpretations, how far away stuff is. Doesn't work. Because you get a number that's significantly different than the other one. And the two numbers are roughly 68 and 73 megaparsecs. And again, that is an inconceivably big number. A light year is 5.88 trillion miles, right? And then a parsec is 3.26 light years. So 3.26 times 5.88 trillion. And then a megaparsec is a million parsecs, which means it would be 3.26 million light years. Now we have 5 of those. So we have like over 16 million light years off. Unless I messed up somewhere. We have an insane discrepancy. It's not just like no big deal. It's called the Hubble tension. It doesn't work. They keep repeating it, keep doing it. It doesn't work. It doesn't work. Let me see if... Let me see. Okay. I was going to say we'll watch one more because it's got Neil deGrasse Tyson on it, but we don't have to watch anymore. I feel like I tortured you guys enough. So, simply put, the model doesn't work. And this is one of many reasons, but this is a serious problem because it's coming right at the core of everything. And now think what you think of James Webb, whatever. They're like, oh, well, James Webb's going to go out there and show us that actually our previous understanding was wrong, but we can still keep everything right because we just misunderstood one part, and they picked up the easiest thing to change. That would kind of fix the problem. But when they start to get their results back, it shows that the measurements were correct. It didn't fix the problem. So now they're in a tricky situation, right? Now, obviously what's going on is all of their interpretations are incorrect. They're interpreting the data incorrectly. They're shoving an assumption of expansion down the sky's throats. It's not expanding in all directions. It's not going 4 times faster than the speed of light. It doesn't create the illusion that everything's in the center. The Earth is in the center. The sky, the cosmos, moves around the Earth. Problem solved. No Hubble tension problem because there's no expansion in the first place. No dark matter problem because it doesn't matter how fast the galaxies move. It's fine. Relativity is pseudoscience anyway. There seems to be a more dense medium. There's no dark energy problem because there's no energy required for the acceleration of the universe because there's no required acceleration of the universe. So the geocentric model is sitting over here just chilling. Doesn't have the Hubble tension problem, doesn't have the accelerative expansion problem, i.e. the dark energy problem, cosmological constant. Doesn't have the cosmological constant / dark energy problem because there is no accelerative expansion. It doesn't have the rate of expansion problem, i.e. the Hubble constant, specifically the Hubble tension problem, because there is no accelerative expansion. It doesn't have the dark matter problem because we don't need to explain some discrepancy in relativistic assumption with this universe that they believe in. The galaxy rotational speeds are fine. We don't have to cram gravity down its throat. It's fine. We don't have the dark matter, dark energy, none of these problems. None of them. When I say we, I mean someone that accepts the observations for what it says, which is that the Earth's in the center. So, anyway, once again, to reiterate, okay, you have the cosmological constant. Let's say it the other way. You have the Hubble constant. Of course, named after Edwin Hubble. Again, 1925, looked out, saw, why is everything redshifting? There should be redshift and blue shift everywhere. Things in the far distance shouldn't care about the Earth, but everything, including distant galaxies, are moving in relation to the Earth. This is weird. Okay, they updated their model to say, well, it just looks like you're in the center. It's an illusion. So sure, it matches exactly what the geocentric position says. It's directly the opposite of what the heliocentric position predicted. We'll just change the heliocentric position and say it was an illusion, and it looks like you're in the center no matter where you are. And every one of their analogies is stupid and doesn't work. They're like, blow a balloon up. That came from a central point. Bake a cake with raisins. Came from a center point. A singularity of a big bang and everything expanding in all directions. That's a center point. That's a central point. How do you have a little tiny singularity, like a little point here? How do you have that singularity? How do you have the singularity? And then everything explodes and expands out from there, but you don't have a center. It doesn't make sense. So, anyway. So they change it, right? Because in 1925, Hubble's observations don't match the heliocentric prediction. They say, it looks like we're in the center. Don't worry about it. Don't worry about it. People smarter than you figured it out. Trust me. We don't know, but we know that we're gonna know, and you're not smart enough to know that we don't know. So we're gonna tell you that we do know, and what we don't know is just an exciting aspect of science and discovery, and it's just a mystery that we're excited to discover. So you have the Hubble constant, because what did they have to say to explain away the observations? Everything's redshifting because everything's expanding, accelerating and expanding away from us in all directions. That's why it makes us look like we're in the center of the entire universe, even though we're not. It's just an illusion. So they said everything's expanding. Okay, the rate at which everything expands away from us, the universe specifically, Hubble constant. Okay, Hubble constant. Everything expanding away. Cosmological constant. Einstein referred to it as his biggest blunder. They've now had to bring it back in because they need it to explain the discrepancies with how fast they need this universe to be expanding now and how much energy they have to make it expand. Okay? That's the cosmological constant, the energy needed to cause the expansion. Right, and that's where, again, you've heard the 10 to the 120th power number. The biggest discrepancy in the history of science, we're off by 10 to the 120th power. That's about, they went and looked at a quantum vacuum, and in the vacuum chamber, there was still lots of energy there, which there is lots of energy in a vacuum chamber that cannot be explained by gas, for those flat earthers that don't seem to get that. There's no such thing as a perfect vacuum. That's a non sequitur. So thank you for your completely useless and retarded input there. But anyway, the truth is that they're hiding the ether, and we all understand that. But they tried to take this energy, like, this will help us out, because that's a vacuum. So if space is a vacuum, but there's energy in these vacuums on Earth, well, that must be what's causing the expansion, right? That must be the cosmological constant. It must be the energy inside the vacuum chambers on the Earth, because we have a vacuum in the sky. So that must be, doesn't work. Way too much energy. Way too much energy. It doesn't work. It's off by 10 to the 120th power. So now people say, we don't agree with that. That must not be right. Of course you don't agree with it, because it destroys your freaking motto. It's 120 zeros. So whatever. CMB is said to be the oldest light in the universe. What is the dating method for light globers? Hank, thank you for the $5 super chat. They're just going to say oldest because they claim it's the furthest away, which means it's old. Right. Which is, again, why I said, we don't know the age of the universe yet. Then he said, it looks like it's off by 1 billion years, which is 7% of the age of the universe. We don't know the age of the universe, but 1 billion years is 7% of the age of the universe. Like, what? Who wrote your script, bro? All right. So I think everyone gets it, right? Cosmological constant, Hubble constant. Now, Hubble constant, rate at which the universe is expanding. They look out. They have two different methods. They have the cosmic microwave background, and then they have the ladder method. Okay? When they tried with the ladder method, it didn't work. It didn't match the CMB. It's off by about 5 megaparsecs, which is an insane number. They keep doing it over and over and over. They keep getting the same results. They say it must be instrumental error. One of the methods we have are just wrong. We just need to refine them and get them closer together. It just must be instrumental error. So something about the way that we're doing the two methods just don't match. It's not that our model's wrong. It's not that we're assuming expansion is there when it's not. It's not that we're misinterpreting all this data as if to be evidence of expansion. That's not possible, nor are you even allowed to dare suggest that. That's heretical. You'll be burned at the stake. What it is instrumental error. Well, it just keeps going over and over. Same thing, same thing, same thing. So they just kind of tuck it away. You've never heard of the Hubble tension unless you heard me talk about it with Professor Parks when he came on. The average person's never heard of Hubble tension. Why? Well, because it doesn't work. It doesn't work with the model. It's a major discrepancy. It doesn't work. So it's bad. It's bad for them. And there's so many things that we're going to cover on here that's bad for them. And we've already done it, right? Just 8 episodes in. But you have the horizon problem, right? You have the flatness problem. You have a whole array of fine-tuning problems. There are all kinds of things that have been well known and are sitting right in front of everyone that have refuted the model. It is wrong. It's irreparably wrong, period. They hold on to it with like just dying hope, right? And they'll do it until the end of time. We've seen that they'll do it for over a century. So they'll do it forever. The only options are sit here and just call it an anomaly that isn't explained yet and ignore it, or make up a new story to explain it away. That's the only 2 options for them. The obvious option is consider throwing your theory and model away. It seems to be wrong. It seems to not actually address the evidence properly. No. Wait, isn't there a model that was once understood and everyone says it's not true, but it does actually explain all the phenomena and would explain all these problems away? Doesn't there exist a viable model? You've been sitting here for 100 years, but there's a viable alternative is that the Earth's in the center and not moving. Not even an option, bro. You won't even get published. Why don't you publish a paper? Well, because people that are literally lifelong astronomers that went to some of the most prestigious schools in the world write papers about geocentrism and doesn't get published. Maybe that's why. Andy, thank you for the $10 super chat, brother. Much love. All right, so I'm going to create a Zoom. And I'm going to go ahead and say this. When we had a bunch of flat earthers come on, people were interrupting and talking over, and it was really chaotic. So we're not going to do that anymore. I want people that want to defend the heliocentric model come on this show, and on Wednesdays, people to defend the globe. I love you guys, but it's about these 2 subjects. We'll create another show where people can come on and talk or something. But I don't want like a group like people laughing and interrupting the person that has the guts to come on here and speak. I don't want interruptions. I was pretty frustrated about the amount of interruptions, so I'm just gonna go ahead and say, like, if you were to be in here and not really talking, that's okay. But I don't want people in here interrupting and laughing, and it just kills the whole conversation. All right. So I'm going to drop the Zoom link and pin it in the chat, and then we're going to start to watch Neil deGrasse Tyson and comment, and hopefully people come on. I have no idea what he's going to say in this video. Let me create a Zoom really fast. In a world. Etheric Productions. Copy invite link. All right. The Zoom link is pinned at the top of the YouTube chat. The Earth is a globe because of plywood. That's hilarious. Holy crap, dude, you're still talking about the globe? Where's your flat Earth evidence? Stop deflecting. This show is literally not even about if the Earth's a globe or flat, buddy. Try to keep up. Try to keep up. You're gonna have to spend more than $5 for me to be reading you, bro. All right. But this what's funny, bro. Like he won't acknowledge what the stream's about because it's just so none of them have any answers. Like they don't think for themselves. They being the people that just mock other people for questioning the current model. Like they don't think for themselves. So they're like, scientists have done this for me. I'm not an expert. There's no explanation even according to the experts. It doesn't work. It's off by 5 megaparsecs. My dude, that's a lot, okay? 1 light year is 5.88 trillion miles. A parsec is 3.26 light years. A megaparsec is 3.26 million light years. The Hubble constant measurements using the latter method in the cosmic microwave background have a consistently observed discrepancy of roughly over 5 megaparsecs. That is not good, bro. That doesn't work. They keep saying instrumental error, and they said James Webb will help clear it up for us. It shows that their data still doesn't work. That's the truth. Hubble constant measurements using the latter method in the cosmic microwave. All right, cool. I was about to say your stuff's feeding through. All right, I'm about to add you in. We'll just go ahead and add you in. Hopefully you believe in this heliocentric model. Oh. All right, Ryan, what's going on? Ryan, can you hear me, bro?
Yeah, I can hear you.
How's it going, bro?
Good. How are you doing?
I'm good.
Good.
You believe the Earth's a ball that flies around the sun?
I'm actually just here listening in.
Okay.
Is that all right?
Okay. Yeah, that's fine. That's fine.
But no, I don't.
Okay.
To answer your question.
Yeah, cool. Yeah, we got to prioritize those that believe in the sense.
Okay.
Somehow, I don't know how to get you where you're not allowed to come on here, Brenda, but Brenda is back to get kicked off again. So before I kick you out of here, Brenda, do you have any plausible explanation for the Hubble tension? Okay. Awesome. All right, so Ryan, I'm going to ask you to mute. What we're going to do is play this 10-minute video from Neil deGrasse Tyson. Like I said, the Zoom link is dropped in the YouTube chat. It's pinned, so you guys can join. Anyone that believes in the heliocentric model, just come on, talk to us about it. Maybe you can help win us over to your heliosexual worldview. All right, so we're going to play Neil deGrasse Tyson, and then we're going to go from there. Let me screen it here. And what I'll do for you guys, so you can hear it, Ryan, I'll share screen so you can hear the video as well.
Okay.
The age of the universe is one of the most fascinating questions that humanity has ever asked. Through a range of measurements and observations, scientists have determined that the universe is approximately 13.8 billion years old. This age estimate is closely related to the so-called Hubble constant, which measures the current expansion rate of the universe. A higher Hubble constant means the universe expands faster and is therefore younger, while a more slowly expanding universe is older. However, these methods produce different values for the Hubble constant, leading to the Hubble tension and the cosmological crisis.
Well, so
Dun, dun, dun.
old-timers, it's hard to call it a crisis. It is a crisis, but for old-timers, it's really hard. I'm an old-timer. I come from an era, an epoch, okay, where we didn't know the age or the size of the universe, because they're related, to within a factor of 2. Is the universe 10 billion years old, or is it 20 billion years old? And if you put all the data together, people sort of picked and chose and sifted, and there was the 10 billion year camp and the 20 billion year camp, and they were warring factions for many years. This is how you get this divide, and it's on the frontier. And eventually, with better telescopes, better data, which is how this is always solved. So, with this factor of 2 warring factions, with new data, especially with the Hubble telescope, and the observations of the cosmic microwave background with 3 satellites that were engaged in this, one successively more precise than the next. So it turned out the uncertainty was no longer a factor of 2, it narrowed. And of course, the actual answer ended up somewhere in between. All right. So we're now at about 14 billion years. No one is saying 10 or 20 anymore. All right. So you'd expect that. If the two warring factions, the right answer is probably somewhere in between, as it turned out to be. All right. So we're all happy, 14 billion year old universe. And then people start looking more carefully at it. They use this method and that method, and our observations are so precise. The Hubble constant version of the age of the universe is the Hubble constant 50 or is it 100? That gets you these two different ages of the universe. If the Hubble constant is 50, then the age of the universe is 20 billion years. If the Hubble constant is 100, then the age of the universe is 10 billion years. So, but point is, those two numbers.
Let me read these super chats, man. We get it, you can't comprehend large numbers. What's your point? That is one of your problems. You actually think the Earth flies. Hello. Oh my goodness. All right. Prior, buddy, jump in, call in the show if you have so much to say. If not, I'm not going to keep reading $5 super chats that insults me. I'll come back when you name a piece of technology you're using created by a flat earther. Wow. Okay. The Will. Thanks for playing. All right, moving on.
Which used to have a huge uncertainty, no longer has a huge uncertainty, but now they each have their own camps because the uncertainty in each number excludes the other number. So if you put the uncertainties around those two numbers.
What did you say, Brenda?
We can't hear the stream in here. Witsit?
Okay. Go back on mute, please. Okay. Let me just reshare with you guys real fast. Stop share. Screen. Share sound. And let's continue.
Numbers, the uncertainties don't overlap. Had those two numbers had uncertainties that overlapped, then it's just a matter of time you get some better data. So that's a crisis in cosmology.
One way scientists measure the Hubble constant is by studying the cosmic microwave background, CMB radiation, which is the leftover radiation from the Big Bang.
Light doesn't travel particularly fast over cosmological distances, 186,000 miles a second. That means that as you look out to even nearby objects, let's say the closest object you can see with the naked eye, the Andromeda Galaxy, if you look at that, it's about 2 million light years away, it means you see it as it was 2 million years in the past. You look at more distant galaxies, 10 million light years away, 10 million years in the past, and so on. So you could ask the question, well, in that case, are there objects that are so distant that the light traveling from them began its journey close to the Big Bang itself? Is that possible? And the answer is yes. And that light was first detected in the 1960s. It's called the cosmic microwave background radiation.
The CMB is believed to be nearly uniform in all directions, with small fluctuations that can be measured and used to determine the Hubble constant. There is also a different method astronomers use to measure relative distances in the universe. This is known as the cosmic distance ladder. It relies on using different types of objects as rungs on a ladder, with each rung providing a way to measure distances to more distant objects. The first rung on the cosmic distance ladder is the measurement of distances to nearby stars using the technique of parallax. This involves measuring the
Okay, so the first part of their ladder is parallax.
apparent shift in the position of a star against the background of more distant stars as the Earth orbits the Sun. By measuring the angle of this shift, astronomers can calculate the distance to the star. The next rung on the cosmic distance ladder is the measurement of distances to nearby galaxies, using a type of variable star known as a Cepheid variable. Cephids have well-known relationship between their intrinsic brightness and their period of variation, which allows astronomers to determine their distance based on their observed brightness.
Now that's how they're always going to tell you what's going on, that they can determine the distance, right? So just remember the video we just watched. Turns out they're like, oh, maybe this is completely wrong because something's wrong.
Further up the cosmic distance ladder are other types of variable stars, such as supernovae, which can be used to measure distances to galaxies at even greater distance. By using these different rungs on the cosmic distance ladder, astronomers are able to measure distances to objects throughout the universe and build a more complete picture of its structure and evolution over time. Resolving this tension is one of the most pressing questions in modern cosmology and may require new and innovative approaches to measuring the universe's expansion.
It may require you scrapping your model because it's consistently not correct.
This discrepancy could be an indication that there is another ingredient in the universe that has not been observed yet. One promising...
Another ingredient? Don't we already have undefined dark ingredients? How many dark ingredients does it take to make a cosmological cake?
Candidate of this additional ingredient is known as early dark energy. The idea behind early dark energy is that the universe went through a phase early in its history where dark energy had a higher energy density than it does today.
Early dark energy. Duh.
This would have affected the expansion rate of the universe, making it faster during that early period. As the universe expanded and cooled, the energy density of that early dark energy would have decreased, and its effects on the expansion rate would have diminished. This could potentially...
So our next episode is going to bury this. They cannot just move around the early energy density. It's already a huge problem for them. It's called one of the biggest fine-tuning problems. It's called the flatness problem, which is that it had to have just the right amount of energy density so that the entire universe expanded just so happened to be flat. It's a very small probability. It's like basically impossible mathematically that it had just the right energy density to expand and be flat. Now they're trying to say that there's early dark energy, but mind you, something that they can't define, dark energy, that there's an early dark energy that has a different energy density. They can't fluctuate the energy density. This is what they're not going to tell you. That's why this is a direct refutation of their model.
Solve the cosmological crisis and reconcile the different measurements of the Hubble constant, since the higher expansion rate during the early dark energy period would result in a higher value of the Hubble constant at that time, which would then decrease to the current measured value as the early dark energy density decreased.
We're getting progressively better observational constraints. So, different theories of what it might be predict different sorts of behavior for the evolution of the universe. And we've been measuring the evolution of the universe now. And the data appear to agree with the predictions of a constant density vacuum energy, a 0-point energy. But one can't prove that that's what it is, because one would have to show that the measured numbers agree with the predictions to an arbitrary number of decimal places. And of course, even if you've got 8, 9, 10, 12 decimal places, what if in the 13th one, the measurements significantly differ from the prediction? Then...
Oh, mind you, it's nowhere even remotely close to that. It's off by 10 to the 120th power.
The dark energy isn't this vacuum state, ground state energy of the vacuum. And so then it could be some sort of a field, some sort of a new energy, a little bit like electromagnetism, but very different from light, that fills space. And that type of energy could, in principle, change. It could become gravitationally attractive, for all we know. There is a historical precedent to that, and that is that the inflation with which the universe began, when the universe was just a tiny...
They're slipping it in, all right, but it could be electromagnetic in nature, but nothing like light. Even though light's electromagnetic radiation, you clown show. And that it turns into gravity. Where are all these people calling me so stupid when I say gravity's nothing more than you hijacking electromagnetic phenomena? All of a sudden, your model is throwing that around left and right. Oh, there must be an early version of something that's basically electromagnetic that, I don't know, eventually is gravitationally attracted. What a joke.
Gravity is an observed phenomenon.
Blink of an eye old, a trillionth of a trillionth of a trillionth of a second. The universe went whoosh, it exponentially expanded. That dark energy-like substance, we call it the inflaton, that which inflated the universe, later decayed into more or less normal, gravitationally attractive matter. So the exponential early expansion of the universe did transition to a deceleration which then dominated the universe for about 9 billion years. And now this small amount of dark energy started causing an acceleration about 5 billion years ago. And whether that will...
So they literally say that dark energy just like changed and now it's accelerating the universe. Yeah, they will literally just make anything up, dude. And people will buy it too.
Continue or not is something that we'd like to answer, but I don't know that we will anytime soon.
While early dark energy is a promising idea, it is still a relatively new and untested hypothesis. Researchers at the Max Planck Institute for Astrophysics have now narrowed down the properties of this new type of energy, using a complementary statistical method known as the profile likelihood, which is common in particle physics but rarely used in cosmology. More research is needed to determine if early dark energy can fully resolve the Hubble tension. Additionally, early dark energy would have other effects on the structure and evolution of the universe, which would need to be carefully studied to ensure that they are consistent with other observations. While discrepancies between different measurements remain, potential solutions are being explored that could shed new light on the fundamental properties of the universe.
Funny how he doesn't tell you what it is, which I just did, which is that they need a very specific energy density to make the whole universe expand out and be flat. It's called the flatness problem.
And its evolution over time. The James Webb Space Telescope will be instrumental in studying the properties of supernovae, the large-scale structure of the universe. By using the James Webb Space Telescope and other cutting-edge observational tools and theoretical models, cosmologists will continue to probe the mysteries of the universe and attempt to resolve the ongoing cosmological crisis. While there are still many unanswered questions and challenges ahead, the pursuit of knowledge and the quest to unravel the mysteries of the universe will undoubtedly lead to new discoveries and advancements in our understanding of the cosmos.
Okay. So let's stop screen share. Come over here to Zoom. All right, you guys are on cameras now, just so you know. All right, so we got some people in here. I know Ryan and Hank do not believe in this pseudoscience. You're just making yourselves look dumb. Okay, perfect. Hebe, you want to come off mute, my guy? You're talking crazy in the Zoom chat, so you can just come off mute. Come on, bro.
Hello.
What's going on, man?
Hey. Well,
so we're just making ourselves look dumb, so I figured you can explain the Hubble tension for us.
Well, see, first of all, you're coming across really aggressive and you're patronizing me. That's NASA, so I just...
All right.
That's NASA. You're telling me that you know more than NASA. It's laughable.
So now we're showing the whole YouTube your messages because he literally just claimed to be a victim. I guess he didn't think I would just show everyone what he's been saying in the chat. But you flirts think you know more. Hey, buddy. Rule number 1 is no interrupting. Okay. Rule number one, you're interrupting. So you flirts, Brenda, I will kick you out. You flirts think you know more than the smartest humans building into each other for hundreds of years. Modern science maintains the entire civilization that you take for granted. You're making yourselves look dumb. Okay, so the fact I said, since apparently you're so much smarter than us, you could help us understand Hubble tension, isn't patronizing you after you were saying all this nonsense in the chat. So now we're going to let you come off mute, okay? And you can explain to us what's going on with Hubble tension.
Well, first of all, I didn't mean to interrupt you. I'm not trying to be rude, but I'm just saying that I'm not going to talk over you. What was your question?
Well, you said that we're making ourselves look dumb, so I figured, okay, then you should be able to explain Hubble tension then.
Okay, but I'm not an astrophysicist or a NASA employee or I'm not an astronaut. I'm not the whole world is built, and you're taking it for granted. Everything works, even the technology that we're using right now. You're saying that this doesn't work. What is this, magic?
Okay, That was just a really low level straw man. When did I say technology doesn't work? It's just magic. So what you really mean,
like you're questioning like the people who, like, you know, basically they make like all this technology. Like
Who?
it's kind of like the same, right?
Who?
Like, you know, the people who make like the technology, you know, like NASA, let's say, for example, or like Apple. I don't know.
When did I question Apple?
No, I'm saying like NASA and Apple, like, you know, it's technology. It works. Obviously, it works. We're using this technology and it's working. You're saying
Okay.
like, what, it's not working?
Who said it? When did I say it's not working?
Man, I'm not putting words in your mouth. Relax.
What you're saying doesn't even make sense.
You're questioning like what, NASA? Well, so
what did NASA invent? What did NASA invent?
What did NASA invent?
Yeah.
What do you mean? What do you mean? NASA invented like. What do you mean?
Name
like
one thing.
Like all the high tech. I don't know. I guarantee like half or more the technology we're using right now was probably funded or, you know, worked on by NASA.
No.
By NASA employees.
No.
Etc.
That's not true. And actually, most of them they claim to have invented. They didn't. There were patents predating them. And what they do is take our money for research and development, and then they sell the patents to private companies and make tons of money off of it, even though we paid for the research and development of the technology in the first place.
So they do.
None of that. They make some things.
You don't even.
They make some things, but you couldn't even name one thing. You're just trying to chant. So
no, but I told you.
Let's get back to actual subject. Let's get back to the actual subject. Hubble tension proves your model is wrong. You said that it makes me look dumb. I asked you if you could explain it. You don't even know about it, even though honestly, I just did a stream.
You're not even giving me like a fair. I don't really even know, dude. You're saying I just came across this. I stumbled onto this. I think it's insane. I tried the link. It actually works. I can't believe it. It's funny, but and like what? See, the link works. I click it. You think that that's like magic or something?
What does that have to do with the Hubble tension?
I don't know what Hubble tension is.
You don't even know how computers work.
I'm not a NASA guy.
What do computers working have to do with any of this?
Well, you're talking, dude. I don't know what you're talking about. This NASA, whatever you're saying. Tension.
I can explain it to Hebe.
Yeah, I would like to hear your.
Yeah, please explain the Hubble tension.
So I know what you're talking about.
Explain the Hubble tension.
There is a discrepancy of about 10% with a 2% error between measurements of close to the Big Bang, which is way back in time, to close by stars and galaxies, which is more contemporary. There's a discrepancy. The two numbers don't add up together, and there's no theories. We have no theories to explain for why that is.
Yeah, but they're supposed to add
up.
I
summed it up correctly, didn't I?
Yeah, I just did a 45-minute stream on it.
Yeah,
so
he wasn't listening. He wasn't listening.
Okay, but
no, I just got in right now.
My point is, Brenda, you don't get brownie points for repeating what I just covered. But what I want you to explain.
You asked me to explain it to him.
Oh, that's fine. But my point is,
so just relax, dude.
Okay, but do you agree that it goes against the prediction of your model?
There's a conflict, right?
Right.
There's a conflict between the Big Bang and current estimates of the distances of nearby stars and galaxies. Yes.
Okay,
There's
so
10% discrepancy.
It's a huge discrepancy. It's like over 5 megaparsecs. So, either one of you guys,
10%,
can you
10%?
Does that mean no? You trying to minimize it? It's huge. It's well known that it's a huge problem. This dude is appealing to NASA and astrophysicists, saying I claim they're wrong.
To say. So you're saying, so is this like a NASA, like this number is given to you by NASA, and you're saying it's wrong?
It's just science today. It's just astronomers today.
Yeah, all the people that you invoked, you were like, you think you're smarter than the astrophysicists and NASA and the scientists.
Yeah,
they're the ones that say this. They're the ones that say it.
Well, it's not just them. It's astronomers at universities too.
Okay, that's my point. The very scientists, you're like, oh, you think you're smarter than them? They're the ones that say this. They acknowledge this as a problem. So what you were saying was just ridiculous.
Yeah. So what is the problem? This is cutting edge of current theory. What's the big deal with it?
No. This is one of the base tenets of your theory for over 100 years.
Yeah, but what's the big deal? So what?
What are you talking about? It's cutting edge, like it was just discovered. No, it's over 100 years old.
So?
Okay, so it's not cutting edge.
Can I ask you, do you think, like, is it that, like, you think you're cool because you're going against, like, you know, everything? You think you're cool? And you think you're, like, smarter?
He's a flat earther. He doesn't believe atoms exist.
Right, so is it because, like, an ego thing?
Well, I think you're probably projecting as you came. Brenda, you're not going to take my show over. Brenda, you're lucky that you're even allowed on here. I've had to kick you off 5 times.
Well, then you wouldn't get any globe earth.
Okay. You're projecting as you came on here for your own ego and started like trying to tear me down. When truth be told,
all I did was ask a question.
Buddy, why do all ballers have to interrupt? Every single time I talk to anyone that believes in the mainstream model, they have to interrupt. And I know why. And Brenda, if you do it right now, okay, Brenda, last time I'm going to warn you. This is why you guys have to interrupt. Because as I begin to lay my point out, if you leave it alone and allow me to lay it all out uninterrupted, it completely destroys you guys. So you have to try to interrupt it and stop it because you can't even hear it. It makes you freak out. That's why you do it.
That's not the reason. That's not the reason, Austin. The reason, Austin, is that you don't let other people talk.
I literally do let other people talk. But that's not true. So I've had a professor come on recently, and I let him fully make his point every single time. We had a 3.5 hour conversation. So you guys can just lie, but that doesn't change anything.
See, like, that's the thing. It's like, I'm going to say something, and then you're not done your tirade. It's not like I'm talking over you. It's just you don't stop.
So you got nothing of value again. So the universe is supposedly expanding, okay? But the measurements don't work. It doesn't match.
Okay, like what measurements are you talking about? NASA uses ultra detailed, fine equipment worth so much money. And who are you? And you're questioning it like...
What? No, I'm saying if their data is true, it shows that it doesn't match the model of expansion of the universe. You're lost.
There's 2 measurements, and they disagree with each other. That's a conflict.
Yes, that's right. So,
I'm sorry, what are the 2 measurements?
One measurement is at the early universe, right during the Big Bang, and the other measurement is today.
It's not just the early universe, it's all local regions as well. It's all the background energy. The background energy. It's called the cosmic expansion. Brenda, do you realize that you're on my channel and you keep interrupting me?
Like dark matter?
No, dude. Something called cosmic microwave background. They look out and they see that in the background that's not visible to the naked eye, there's a ton of energy. They looked out.
Yeah, like the stuff that you see on the TV when you change a channel.
No, this stuff is not visible.
That's exactly right. No, the
it's not.
static that you see on your TV is CMB. It really is.
Okay. You can't see the spectrum of the CMB with your eyes.
You can't see radio. Nobody thinks you can see radio, Witsit. Nobody thinks you can see radio.
Dude, think about trying to gaslight me like I'm stupid, and you just said you could see CMB. And then this guy says flat earthers.
The static.
Okay. You're laughing, but I get your... because Brenda's going to disappear. You're not going to have Brenda to jump in and white knight for you, because if Brenda keeps interrupting, she's...
I'm not...
Hey, buddy. Listen. So they looked out at the background, right? And according to the heliocentric model, the universe should be expanding in all directions, and it should be what's called isotropic, which means it has no preferred direction. And it should be homogeneous, meaning that it spreads out evenly everywhere. When they looked at it, it was anisotropic. It did have a preferred direction. And when they followed the cold spots, because all of it's warm and there are these cold spots, when they follow it, it intersects on the Earth, showing that the preferred direction intersects directly on the Earth out of the entire universe. And they called it the axis of evil, because it shows that the Earth is in the center, because there's no logical reason for out of the entire universe for it to intersect on the Earth. They call it the axis of evil. They called it
Okay,
evil.
but why do you care though? Because these are NASA's findings, right? And you don't trust NASA, so why do you
he's
care?
a religious nutter. He's a religious nutter. He's got
Okay, so
No, but I'm saying-
that's called an ad hom. So you can send a balloon up and get background radiation results. So
Have you ever done any like balloon or anything?
no, that doesn't matter. The point is that if even just taking their data, what they did was say, nuh-uh, and they called it evil, and they just ignored it. But what their own data shows is that the Earth is in the center.
So why are you focusing on it at all if you don't trust NASA as a source or anything? Why do you even?
I just explained to you that you can just send a high altitude. Dude, Brenda. Okay, I'm sorry.
You do. You cherry pick.
I have to remove you. Okay.
Yeah, I mean, I don't understand. So they're fooling everybody, including the most brilliant people who know, like, they work in the field for many years and, generations. And, the whole system is built on top of, like, these understandings. And now you're gonna, you know what I mean?
No, I don't know what you mean. So throughout all of history, different branches of science have been completely wrong for hundreds of years. And
Like
all
which?
those scientists thought one thing before that. You weren't aware of that?
What?
Like the fact that they thought that they'd see redshift and blue shift all over the sky because the Earth is tucked away in a little corner. Well, they used to say the Earth was geocentric.
What?
Then they used to say, no, listen carefully. You need to learn things. You're not in an intellectually or superior position here. It's the other way around.
Dude,
You're uninformed.
Okay.
You're uninformed. So an example,
Go ahead.
dude, you asked for an example and you're afraid to hear it. One example is Isaac Newton, who came up with gravity. He thought that the sun was the center of the entire universe. And people thought that for hundreds of years. All of the astronomers, all of the astrophysicists, everyone looking at the sky thought the sun was the center of the entire universe.
Okay,
Yeah.
so that was about the scope of their understanding. So in a sense, isn't that true? If you're limited to the solar system?
It's not even remotely close to true.
If you're only talking about the solar system.
But they were talking about the whole universe, though.
Yeah, but we're talking about like back then when they didn't know that even, let's say there was like Pluto or whatever. They only thought it was like way smaller.
Okay, the point is that as you learn new information, everything that was previously thought can be completely wrong. So to say a bunch of people believe it right now and they're scientists, that doesn't mean it's true. That's an ignorant way of thinking. That makes no sense.
But he was right, though, is what I'm trying to say. Technically, like in a sense.
No, he wasn't.
Technically, he was wrong, but with his limitation, he was right. It's just the scope of the subject was off.
That's my whole point, which is when you get new information, it can show. When you get new information, it can show that your entire understanding was wrong.
No, but he's right. But he was right though in the sense of the solar system.
You're not addressing the point, which is that when you discover new information, it can show that your entire theory is wrong. How do you understand this?
Dude, I do.
You clearly don't.
No, I clearly do because he said that, the solar system, so the sun is the center of the solar system, and that was the scope. Okay, cool.
Okay, cool. So you were wrong whenever you acted like people don't realize that they're all wrong. So what you did was called an appeal to authority and an appeal to consensus. Since so many people think this is true, it must be true. Oh, since the people that
It's
are
not
the
that so many
authority...
people, it's the types of people and generations and everything that we know and everything that has brought humanity this far to the height that it is. You're like scoffing at it. What are you talking about? Like
you don't even know anything about this stuff, though. That's what's so weird about what you're doing,
dude. I know. Okay, let's say I know the average amount, or a little more, or a little less. Let's say I know the average. You're not making sense to me. I would like to hear what your idea is. These people, all their lives trained, generations past, and we've achieved sending satellites and launching rockets and walking on the moon and sending rovers to other planets and Wi-Fi and everything, cell phones, boats, everything that you're saying, like what? That it's not true? Like it doesn't make it sounds you're making
straw man fallacy. When you say it makes me sound stupid, you're projecting, because what you're doing is using something called logical
I don't think you're
fallacy.
stupid. I think that
You're
just,
emotional.
maybe attention seeking.
Yeah, says the guy that screams and interrupts on a random person's YouTube video. So
I screamed and interrupted.
Yeah,
no, there's a little bit of a delay, I suppose. I'm trying not to interrupt. Absolutely, I don't do that.
No, there's not. So you're
Hey,
using.
Can I ask Heave a question?
Sure.
Go ahead.
Okay, so what's the difference between dark energy and new dark energy? Specifically.
Well, that's easy. That's easy.
Yeah.
You sure don't want to? You want to test me?
Yeah. Go ahead and tell me what the difference between dark energy. And
He's
new
literally
dark energy.
Googling it.
Dark energy is old and new energy is new. It's in the name.
Wow. You don't know. Okay. So
I'm gonna go with that.
Yeah, this is the main point, right? What people do is,
I see, like you're falling right
buddy,
into it because it's like
you're gonna have to
talking about
listen
things-
to me finish.
No, but you're talking about things that NASA is talking about, and then you're saying that NASA is like irrelevant, but you're talking about NASA's ideas. So what does it matter if new or old?
I need you to listen. So this is the truth, right? You were just told that the Earth is a ball that's tilted, wobbling, spinning, moving around the sun in a solar system. You were told to make a solar system model, maybe. You were told to remember the planets. You remember the basic stuff, like the Earth spins once a day. It goes around the sun every 365 days. You may know just some of the basic stuff.
Yeah, average.
You've never truly researched. I traveled the United States for like a year. The average that people know is like a third grade level. So being average in this term, like in this subject, is not something to brag about at all. It's pathetically bad. I could ask you basic questions of the model and you wouldn't know them. You wouldn't even know them.
Go ahead.
Okay.
Yeah, I bet there's a lie. I bet there's
okay.
wrong.
What's the axis that the Earth is tilted on? What degree is it tilted on?
Okay. I'm gonna say, I don't know for sure, but I'm gonna say like, I don't know, 12 degrees?
No.
20?
Closer.
25?
23 and a half. But isn't that obvious that you don't even know that's a basic part of it? How fast does the Earth spin? How fast does the Earth spin? How fast does the Earth spin?
How fast does the Earth spin? Like miles per hour?
Sure. Or even degrees per hour.
Degrees per hour?
Yep.
What do you mean? That's not a speed, degrees per hour.
Okay. That's an angular velocity. So do you want to tell me what the speed is in miles per hour? Do you even know? Let's say at the equator.
I would say 1,000 miles an hour.
It's roughly 1,000 miles per hour at the equator.
Oh, so I'm doing good. I'm basically 2 for 2 because I was
you're
close
not.
on the other one.
You're not.
Well, I was close. I don't live and breathe this like you do.
This isn't living and breathe. These are basic, like 5th grade questions.
Yeah, exactly. And but dude, a second ago you said 3rd grade, and if that's true, or 5th grade, then I haven't seen any of this since then, and I know this. So
okay,
yeah,
but that's my whole point, actually, right? Like, wait, surely you know this one. How far away is the sun in your model?
Oh man, something crazy, like I don't know, 1,000,000 miles or something.
No, not even close. That's like 1% of the. It's 93 million. Okay, so which has changed like 13
I said
times.
100 million. There you go.
Yeah, after you said 1 million. But my point here is that people that come in and they scoff and they talk down to the people that discuss this conversation, they themselves don't know anything about it. They barely even know the basics.
More down to me and my friend over there. I'd try not to offend you.
Okay.
I'm trying to be polite.
So try and pay attention to the point here. The people that come in and they're so cocky and arrogant and they talk down, you look so dumb. They use the word flurf and stuff like that. They bring up technology, right? That they don't even understand the technology or how it works. They lie about how we deny technology and call it magic.
You're saying you do?
all that is just weird that you lie and you say that like we have to deny that technology works. It's called gaslighting, right? You're just gaslighting. You're poisoning the well.
So what is the lie? Like, where is the lie? Like, for example, like like you tell me what they're lying about for real. Like this phone I know is because I'm using it right now. I'm talking to you. What else is the lie that what other machine or like is there a robot that there is just a video but they're pretending is real or something?
What are you talking about? Why can the phone not just work the way it works? Why do I need to believe the phone doesn't work? Like, what are you even thinking in your mind?
I'm asking you, like, where are they lying? Like, what's the lie? Other than their model? Like,
that's what we're talking about.
The technology. Yeah, but they say that they have this model and they use that model to, let's say build a rover or whatever. It works. Obviously.
No, they don't.
So how are they wrong?
They don't use that model to build a rover. Everything that we build on the Earth, we assume the Earth is flat. We assume the Earth
is gravity and stuff.
Wait, buddy, listen. If we're gonna apply your logic, right, and if you build technology using a certain model, then it's evidence for that model being true. Well, we build everything. We build everything on the Earth as if the Earth is flat and stationary. Literally, like everything.
Yeah, but it might as well be because the sphere is so large.
Okay, so now all of a sudden, it's not evidence for that model because it's not the one that you want to believe in.
No, it's just that you're being hyper specific.
I said everything. How is everything hyper specific? Literally everything.
No, as in like, it's so big that there's like it feels flat if you're so small. Like it's like putting like a little water bear, whatever those little microscopic things are, on a basketball. You know what I mean?
Okay, let's try this. Would you admit that you don't actually know why you believe that the Earth moves around the sun in the solar system, but you just blindly believe it because you trust that other people did the work for you?
Oh, wait a minute. Okay, because that's kind of BS, because like you don't know how you were even born or whatever, let's say with a spirit or a soul or whatever, but you don't know, but you are. So what's the difference?
Okay. Do you agree that the reason that you believe the Earth is a ball that flies around the sun in a solar system?
Standing on the shoulders of giants.
So, right. So
yes.
You don't really know what all the model claims or the claims within the model. You just blindly believe it because you think that other people did it for you.
No, but because it's like that's what I was saying with like the technology. It's like, it's like they think, right? The model is that there's a neutron and an electron and a proton, and you can't see that. But with the way the model that we have is, it kind of says that it's true.
What?
Because it works.
Why you keep on changing the subject?
I'm just using examples.
Bro, can you address what I'm saying? What evidence do you have that the Earth flies around the sun?
I guess I could look up and I see movement.
Okay, so the fact you see stuff moving in the sky is evidence that it's not actually moving in the sky, but rather we're moving?
What?
Well,
yeah, the fact that everything is moving above me. If I were to go, let's say, to a star and travel there, the star would get bigger. So I assume that because it's far away, it's small, and here is big because I'm close to it. So I assume that they all have like the same, they're all like circle things, you know what I mean, like ball things, and they're all moving. So I assume since they're all moving, why are we different? We're all moving.
Okay, but the model claims that when we see that stuff move, it's just an illusion, that they're actually not moving relative to us. We are moving,
no,
so it makes
moving. It's all moving.
No, use the sun for example, right?
Sun's
so we see the sun move in the sky throughout the day, right? It's over your head at noon, right?
Yeah,
see
but
the sky.
Let's say other than, let's say, just take the Earth out of the equation. Is the sun moving?
Okay, we're not going to take the Earth out of the equation because you need to understand this basic
It doesn't
part.
matter if the Earth is in or out
Buddy,
of the equation.
buddy, I
Is
need
the
you to
sun
pay
moving?
attention, please. Pay attention.
Is the sun moving?
I know the sun's moving because we observe it to be moving, but
I'm saying
your
it's
model
moving too.
claims it's just an illusion. So when we see, that's why I said it's so important that you don't even truly know what
Dude,
you believe.
The sun is circling around the Milky Way.
Okay, but that's not why it moves in our sky throughout the day. We don't ever see
I know
that
it's
move.
not. I didn't say it was, but we're talking about just bodies moving.
No, we're actually talking about one thing right now. We see the sun move in the sky throughout the day. Okay? You said that evidence that we're moving around the sun is because we see stuff moving in the sky. But the globe model claims that the Earth is spinning, you just can't feel it, so it makes the stuff in the sky, which is still relative to the Earth, look like it's moving. It's just an illusion. That's what your model says.
Okay, so it's like, if you get like a basketball, for that example again, let's say, and then you have like a microscopic organism, and I go play basketball like an entire game with that ball, and then you look, the organism could probably still be on the basketball. You know, it's it's relative.
That's not even the point, bro. Like, I know what the explanation is.
Does that little organism feel that its surface that it's on is moving?
Bro, listen, man. I know the explanation. It's all relative. The Earth is so big that based on the motion relative to the size, you can't tell it's moving. It's okay. It's specific with relativity that it's equally valid for either the Earth to be moving or to be stationary, and that they look the same. And there's a kinematic.
Exactly,
it's called a kinematic equivalence. Not the point though. The point is, when I asked you for evidence that we move around the sun, you mentioned us seeing the sun move. That doesn't show us.
I said the bodies.
What bodies?
The bodies above.
What bodies?
I said like circles, balls. The
like
things
what?
Above my head when I look up.
Like what? Like stars?
Yeah, like, well, they call them planets. So let's say the planets. Yeah, planets, stars, sun.
Those are different things. Oh, okay. So we see everything in the sky circle around the Earth. That's what we see. So
see, like, you're wrong, bro. You actually think you're so like perfect, but you're wrong. Like, they have like precessions and stuff. Like, the planets, they move back and forth sometimes and stuff.
That's called retrograde. Yeah. Okay. Okay. But they all do a circle that resets every year around the Earth. You do realize that, right? You don't even know the basic stuff. So everything moves around the Earth once a year. The globe Earth model claims that it looks like that because the Earth is spinning and then doing an orbit around the sun. So it makes it look like that.
There.
Okay. We see everything go around
for the past minute.
No, you weren't. We see everything go around the Earth.
Okay.
Do you understand that your model claims that it just looks like that?
Part that I said. So maybe you didn't hear the part that
I did.
Said that I got cut off. I was saying with like the precessions of or like the retrograding of different. Like,
I just told you it was
Pluto,
called retrograde. I had to tell you it was called retrograde.
No, dude, I'm telling you, I was disconnected. I honestly didn't for the last minute.
You're like basically getting in troll. You're getting in troll territory, man. Like, I don't.
Troll territory?
Yeah, like, I think you're like afraid of this truth or something. I'm asking you what the actual evidence is that you have. You said you see stuff moving in the sky. So what you're saying is
I
that
gave you fair answers that stumped you each time, and you're like playing a game.
What? When did you stump me?
Dude, because you're saying like all these things are moving, or you know, it's moving, you know, compared to us, and you're thinking that because above you they move, and you know, here you don't feel it, but it, you know, you're saying that because above you it moves, so you're saying we move too. And I was
when did you stump me?
I stumped you the whole time.
Just name one time.
Well, I was trying to tell you, and you interrupted the way you don't like it being interrupted.
Oh, you're not answering the question. So you didn't stump me. Okay, but it doesn't matter. This isn't some like ego contest.
I think for you it is.
You have been taught a lie, and you haven't tested it yet. You blindly believe in it. So
No,
it's
I didn't
basically
test
a
it, but it's not
religion.
I'm like, I'm not that's what I'm saying. I'm not like a NASA guy. Like, they've done it, they do it. Okay, they've been doing it, and so many people apparently have been doing it, and there's like evidence that they've been doing it. It's like, dude, this, it's not like, so many people get like, poo in their eyes because they went swimming in the sewer. I don't need to go test it myself.
Wow. Okay. So you blindly believe in it, but you don't even know what
I don't really call that blind belief.
Bro, please stop interrupting. You don't know what it is that you believe
But you're
in.
lying about what I'm saying.
Bro, you don't know what you believe in, but yet you believe in it. That means it's a blind belief.
No. See,
Yeah,
like I said with my example, I don't need to go test it myself if I trust, let's say, not even trust, because I know you're going to try and use that, but if like good sources, and not even good, because not even sourcing, it's like if I have evidence, let's say, that it worked, then I don't have to go test it.
Okay. So what I'm about to do is I'm going to show you a presentation. I'm going to show you all these scientists saying that the Earth can be in the center. Because you seem to be like obsessed with the idea that scientists say things. Okay. And so when I show you all of these, the world's most famous scientists from within your own model saying that the Earth could be stationary, we'll see how honest you're going to keep it. Okay. So let's hear Albert Einstein. Let's start with Albert Einstein. I have come to believe that the motion of the Earth cannot be detected by any optical experiment. He then says, though the Earth moves around the sun. To the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments, we have already remarked that all attempts of this nature led to a negative result. He's saying there's no experiment on the Earth that can actually measure the motion of the Earth, and that he had to put the theory of relativity forward because prior to that, it was difficult to become reconciled to this negative result. And relativity says, oh, well, if it's stationary or moving, it's the same. Albert Michelson says that their test contradicts the assumption that the Earth moves. Henri Poincaré, which is the guy Einstein got his theory of relativity from, a great deal of research has been carried out concerning the influence of the Earth's movement. The results were always negative. Again, Henri Poincaré, the guy that Einstein literally had to steal his theory from. We do not have and cannot have any means of discovering whether or not we are carried along in a uniform motion of translation, meaning flying around the sun. Wolfgang Pauli, the failure of the many attempts to measure terrestrially any effects of the Earth's rotation or motion. Arthur Eddington, there just was one alternative. The Earth's true velocity through space might happen to have been nil. This guy's from the Eddington experiment, supposedly one of the most famous experiments ever that tried to help verify relativity, which is lied about. It didn't. Of course, this guy's a famous physicist, Wolfgang Pauli. Henri Poincaré, famous physicist. Albert Michelson, famous physicist. Albert Einstein, one of the most famous physicists. Hendrik Lorentz, one of also the most famous physicist. Briefly, everything occurs as if the Earth were at rest. I could go through this PowerPoint nonstop. Here's Newton saying that the Earth could be in the center.
I bet you could.
So you're obsessed with scientists. Let's get to some more modern scientists. Let's do that. Here's some modern scientists talking about the cosmic microwave background. Looking into this anomaly more deeply, we will find that it remains robust throughout all 7 years of published WMAP data, and furthermore, that it is very difficult to explain within the context of the canonical inflationary lambda cold dark matter of cosmology, the Big Bang model. The observations disagree markedly with the predictions of the theory. This is them saying that the Big Bang model, the current cosmology, that the results from the CMB do not agree with it.
Okay, so like you said, you could go on forever, and this is your show, and I'm just some random. I don't really know all the stuff practice like you do, so but it's your show, so I let you disseminate that information. But the thing is, it's hard for me to speak against it because there's so many different examples.
Okay, so the actual point is that you're like saying all the scientists know one thing and you have an ego and think you're smarter than them. No, you're just uninformed about it. So I'm going to read this one more here. This is Lawrence Krauss, one of the most famous atheist physicists in the world. One of the most renowned physicists in the entire world. He says, but when you look at the CMB map, which is the cosmic microwave background, you also see that the structure that is observed is, in fact, in a weird way, correlated with the plane of the Earth around the sun. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. That would say we are truly the center of the universe.
Okay, well, I have a good question for you that I think you'd like.
Go ahead.
So these names that you are keep name dropping, what would you say their opinion would be? Which model would be correct? The one that I'm suggesting is most likely true, or yours?
Well, they have different models. Some here, this guy's a geocentrist right here. This astrophysicist is a geocentrist. This guy right here is a heliocentrist saying, uh-oh, we may have messed up. Turns out the Earth might actually be in the center. So even the most renowned scientists, astrophysicists, and astronomers on your side are coming out now with all the evidence saying, we may have messed up. It turns out the Earth might actually be in the center of the entire universe, thus meaning it would have to be stationary.
Yeah. Okay, so, but the thing is, like, these are little footnotes to their entire careers, professional careers, and little footnotes. And, let's say, like, these are trustworthy sources, which I agree with you, they are. Like, you have, Hawking, for example. If they did, let's say they were suggesting that it was not a ball, let's say, for example, they're suggesting that little footnote, it was irrelevant to them and to their peers and to society and the people's opinions that matter in the businesses, enough that it didn't do anything and everyone is still in agreement.
No, actually, it changed the entire model. It made Einstein come up with the theory of relativity, which is the current theory of gravity, which says, oh, it's going to look like we're in the center even though we're not. They literally had to change the entire model because of Michelson-Morley. Now we fast forward to cosmic microwave background, which is a more modern piece of information, which also shows that the Earth's in the center. No, it doesn't. No, it consistently shows that the Earth is in the center. That's what all the evidence every single time shows. They have to keep on changing the model to try to explain why it always looks like we're in the center. So look, there's a whole list of people here. If you go to my Telegram, this is a modern guy, Julian Barber. Thus, even now, 3.5 centuries after Galileo, it's still remarkably difficult to say categorically whether the Earth moves. So people can run around the internet and say that they know it moves and that only science deniers with egos would ever question it, but it's because they haven't done their research. That's why they say stuff like that.
Well, I would say that I do like that you are passionate about real things like the world around us. I like that. And because of that, I'd be inclined to look more into the information that you're showing here, or your website, or whatever. But like I said, the machines and the coordinated effort and the achievements and stuff. How can you deny these things? And
well,
also,
I don't need to deny them. I keep trying to tell you that. What do I need to deny? I don't need to deny any of the technology.
Well, you have all these pictures of all these high achieving scientists, but you're denying what they, like I said, fundamentally all would in the end agree on, even with these little blips of inconsistencies, let's call them.
No, they don't all agree. I just told you that. This guy right here is an astronomer who's a geocentrist. This guy is a geocentrist.
Okay, so, I'm sure that he's a geocentrist, but I'm sure that he wouldn't deny that, what is this? What he would deny the Milky Way? You know what I mean?
our interpretation of the sky is wrong if the Earth is geocentric. It's not deny the Milky Way. It's deny what people think the Milky Way is, how big they think it is, where we are within it, where it is within the whole universe. These are all made up ideas, assuming that we're moving around the sun, but it just can't be detected or measured, and it's a stubbornly persistent illusion that we're in the center. That's what you believe.
Well, it's kind of like whether the Earth is in the middle or the sun is in the middle, the Milky Way you can still see.
Okay. Yeah. But it's totally different if we're not flying around the sun in a solar system moving around the galaxy. It's completely different.
And that's another thing. They take pictures.
What?
They take pictures. Like, they take pictures. I don't know, like Mars or whatever.
Oh, my God. Okay. First of all, I don't believe in that stuff, but even if it was true, that doesn't in any way show us that the Earth is moving. Of course, I don't believe in CGI pictures from the government. That's weird. It's weird to me that adults believe a federal agency showing them CGI.
And it's also weird to follow laws, I bet.
No, no. Wait, do you agree that the government lies?
I mean, it's human nature to lie.
No, the government specifically comes up with lies to trick the people.
Okay, the government is a body, so it's like a bunch of people. So are you saying that there's like a concerted effort and a bunch of people know that there's lies that they're pushing to everybody?
There are times that within the government, they come up with specific lies to deceive the people.
And
they do it all the time.
So there has to be like a crew, at least like more than 2 people, for example, to say it lightly, that know the truth and are not saying the truth, and they're going with this.
Okay.
And they have families and stuff.
Wait, are you saying that you don't think it happens? Because that's the question.
No, I think I think humans lie. So of course there's got to be some sort of, I mean, there's corruption everywhere. So, but I'm just saying, like, I guess, like, it's like they're not gonna, Tesla or Toyota is not lying that they can make cars that go 60, 0 to 60 in, I don't know, whatever, 5 seconds or so.
That's irrelevant. I don't think the government lies about everything. Okay. The government lies, though, like to such an extent that they will tell a lie to the people that will result in the death of millions of people. They literally lied to the American public and said that Vietnam blew up a ship of ours to justify us going and waging war on them and attacking them. It came out decades later. Wait, I'm not done. Then they came out decades later and admitted, actually, we blew up our own ship, tried to make it look like it was them, and then lied to the American public because they didn't want to go to the Vietnam War. So we tricked them with the false flag and claimed it was Vietnam so that the people would be cool with us attacking them.
Okay, so there's 2 things that I could say to that. First of all, let's say it could be some kind of human effort and then they're like covering it up or whatever. Or, that's like military, and part of military, like Sun Tzu, is like, you lie.
Okay, they lied to the American public to deceive them and trick them into doing something they wanted them to do. Now, there's all kinds of examples. They did it with MK Ultra, where they were practicing on brainwash techniques on unsuspecting university students. They were using different frequencies and drugs in their food to literally brainwash them. It's called MK Ultra without telling them. They took over the mainstream. What, the CIA? What do you mean? What do you mean? What does it mean? Well, who knows what they did with it? All they did was admit that they were studying how to brainwash people, and they did it to people within the general public that didn't know about it. Okay.
Okay, but these are like covert, underground, endeavors. We're talking about things that are right in our face, and things that I can kind of just look up and.
Okay. The CIA also said that they subverted the mainstream media, that they infiltrated the news, put news anchors in as agents, and then brainwashed the public with propaganda. The CIA took over the news, admittedly declassified, to be on the news just telling everyone all these news stories, and they were actually CIA agents that were trying to propagandize people. That's called Operation Mockingbird.
I mean, like I said, these are different levels that we're talking. We're talking about like, independent individual experiences with different people versus like the whole world knowing something.
Okay, the whole world knowing something. Who's the whole world know? What? How does the whole world know some type of evidence that the Earth's a ball tilted, wobbling, spinning in a vacuum going around the sun?
Well,
how's the whole world know that?
It's hard to confirm something like that personally, but you take it from enough sources that you can trust.
Okay, we're talking about the if you can trust them part, right? So the NASA was founded with Nazis. NASA has been caught lying. We've caught them editing and deleting live streams. We've caught them using fake pictures. We caught them showing a picture of the Earth from the moon, and then we found out it was actually photoshopped, and then they admitted it was photoshopped. We've caught them glitching out on the ISS. We've got their hands going through items. We've got them grabbing harnesses. We've got people appearing and disappearing out of nowhere. We've caught them lying about space. A company that was founded by Nazis.
Though. It's like even, for example, Tesla,
SpaceX can't go do anything.
Or the Chinese NASA.
Oh, the Chinese would never lie. Have you ever looked at the Chinese videos?
Example, but other countries.
Yeah. Okay, there's not a ton of space agencies. And yes, all of these countries are in a treaty together, the Antarctic Treaty. So it's not like it's impossible that they work together. Also, they can just be like, oh, America claims to go to space. Well, we need to pretend we go to space too. They can fake it also. SpaceX has to work with NASA. They can't do anything without the approval of NASA and the government. Elon Musk himself said that he had to give the government full access to all of his computers, and they get hundreds and hundreds of millions of dollars from the government every year.
You're saying that even the regular people who the regular engineers and all of them, they are being lied to, or they're hiding it, or they're too dumb to prove it themselves?
No, they just believe the lie. Like, they're not in on the lie. Only a very few people need to lie. It's like, I'm going to tell you the story.
Yeah, but so all of them? But they're professionals. They went through so much schooling to learn, angles and stuff and the math. They can't figure it out themselves.
Some of them do figure it out.
They're doing accurate calculations and coming to the same conclusions that NASA and other peers are coming to. And
no, some of them do figure it out. Some of them do figure it out, though.
Obviously not.
Okay, so what about the former NASA employee I know that's a flat earther?
Wow, one
See?
unique.
What about the other NASA employee who's a flat earther?
Oh, the other one. Oh, and now let me continue your thing. What about the other NASA?
No, I literally know of two of them. What about the two astronauts that claimed to went to space, and one of them said, you can't go to space, it's all a lie, and then one of them said the Earth's flat? What about those? What about the astronauts that said that?
Okay, first of all, you're just saying like these at least the other images I knew who they were. Right now, you could be lying just like you're saying everyone
okay.
lies.
Well, I don't lie. So if I'm telling the truth, what is your response?
If you're telling the truth, but that's a big if.
Oh, do you want me to play the astronaut saying it?
You know what? For the audience and myself, why not?
Okay, I'll find it. But is it actually going to even matter to you, right? Because you look like you're just looking for excuses for everything.
You think so? Oh, is that right?
I honestly do. I do. I think you're like scared or something. It's weird.
You think I'm scared of what?
You're scared of a lie this big about them faking space. For some reason, you think that them faking space is like scary.
No, I think I'm just being. No, see, like what you're calling fear is me being more. I guess. To me, it's like I'm calling a spade a spade. That's it. Hello, everyone.
No, you're not. You're uninformed. So here, we're going to show you right here, full screen. And then I'll share it for you. I'm about to actually have one of the NASA employees on my stream. So here.
Everyone,
Oh, did I share with screen? Let me reshare. Or did I not even share with you guys? Okay, I'm about to share the screen. And you tell us what you think about this here.
Excuse me, as I do have a cold today, but I wanted to get this information out as quickly as possible. First, I want to thank the former YouTube channel called Flat Balance for sending me this information last night. The Flat Balance channel doesn't exist anymore, but he still contributes behind the scenes. Now, this same person is the one who originally sent this interview of the former cosmonaut from the Soviet Union named Igor Volk. Igor Volk died in 2017 in Bulgaria several years after this interview that was conducted in 2014. Let's watch my old video. But now we have a Soviet cosmonaut who has said that we have never been to space. This cosmonaut's name is Igor Petrovich Volk. Mr. Volk even received the Medal of the Hero of the Soviet Union. I have included the translation of the interview, which you can verify by clicking on the CC button on YouTube. Now please watch the interview.
Все пак вие сте и герой на Съветския съюз и можем да ви вярваме.
Герой Советского Союза, мы можем верить вам.
Вы знаете, вот
Вижте,
сказал, что вроде чести космонавтов, что они не говорят о том космосе. А им говорить нечего. Я об этом
кара космонавтите да говорят за това, което става в космоса. Те просто не знаят нищо такова. Ние не сме били в космоса. Ако някой твърди това, това не е вярно, не е истина.
Това е поредната хипотеза, над която ще се наложи заедно с зрителите на въпросна гледна точка да размишляваме дълго.
Хорошо.
Добре.
Это хорошо, когда
това
люди
е добре,
думают.
когато хората мислят. Това ми харесва.
Игор Петрович, благодаря ви за участието във въпросна гледна точка.
Моля.
We have an actual former cosmonaut whistleblower who said that we have never been to space. After I published that original video, we heard every sort of excuse from the propagandists. I wish I still had that old channel that was terminated by YouTube because the excuses in the comments section were comical. Some tried to claim that it was mistranslated, but others came out and said that the translation was correct. The propagandists pretty much settled on the claim that Igor Volk was joking. And that's why this next interview is so important. The interviewer of cosmonaut Igor Volk back in 2014 was Stoicho Kirev. But this time, Stoicho Kirev, who is on the right, is being interviewed by the YouTuber Martin Karbovsky. These two men are well respected in Bulgaria. Now, this interview is only 6 days old. That means that this interview was 9 years after Stoicho Kirev interviewed Igor Volk. Let's watch a portion of this new interview.
Не знам, братко, Кавка е казал, този свят не е толкова лош, защото е много лош, а защото е единствен. Къде ходим?
О, колко освен, че хубаво и вярно. Ами, знаеш ли, за съжаление, Илон Мъск не е открил света, на който да отидем. И май няма да го открие скоро. И май нашия свят...
Ще мина директно на конспирациите, няма да се водя по тук, по този план. Той е твърде любезен.
Не дей.
Бяха ли те на Луната?
Бяха чушки на Луната.
Аз ще ви кажа нещо, което мога да ме изложи. Нали? Гледах няколко десетки популярни филма, научно-популярни филма, документални. И вече съм абсолютно убеден, че никой не е ходил до там и американците са перфектни в една изключителна измислица. Ами аз правя документални филми. И ако трябва да покривам несъответствия, те непрекъснато изкачат несъответствия, аз знам, че няма да мога да ги покрия, особено за такъв голям мащаб, особено за по-дълго време. Минаха 50 години. Минаха ли? 65 години беше. По-малко ли са?
50.
И в един момент разбираш, че ние нямаме технологията да отидем до там. И в момента. Аз не се шегувам. Може да ме обиждате, може да си мислите, че аз поудявам, но седнах, мислих, гледах и по време така седях и казах на един човек до мене, абе те май не са ходени там. Седя и мисля.
Кажа нещо.
А винаги съм вярвал. Има и нещо друго, само така крак.
Да.
След това руснаците казаха, че и те са били. После руснаците замълчаха. Кой е бил всъщност на Луната от руснаците? Никой не е бил.
Мой гост беше един от най-великите космонавти на Съветския съюз, Игор Волк.
Да.
Игор Волк остана в България. Той, за съжаление, и почина в България няколко години след гостуването ми. Той остана в България седмица, че и повече, в което време бях с него и съм много признателен за това. Това е космонавта, който е може би с най-странна съдба. Този човек е изпитал всички видове самолети, произведени в света. Да. Този човек в частен разговор ми каза: ние в космоса не сме летяли.
Обикаляме тук наоколо горните слоеве. Нали?
Да.
А в космоса...
А Луната е в космоса. Да. И само това отговаря на този въпрос, над който и ти разсъждаваш. По твой начин.
Не са ходили Армстронг и...
Марто, необходимо ли е някой да ти каже нещо директно, при положение, че дава ключа за...
На повечето хора им е необходимо.
Така ли? Руски космонавт да каже: ние не сме стъпвали на Луната. И да ми го каже при положение, че знае, че утре аз ще го изцепя в ефир.
Единственото доказателство, което се опитаха да направят Mythbusters, беше, че пращаха лъч лазерен до Луната и той се върна, защото американците сложили там някакви огледала.
Дрън пляс.
This confirms that former Soviet Union cosmonaut Igor Volk was not joking. No one has been to the moon. No one has been to space. We have all been lied to big time. Please share this information everywhere.
Okay. There's one of them. And I decided to let the whole thing play because I just wanted to get out in front of the stupid excuses. So.
Yeah, well, I wanted to let you play your video here on your show, but what I want to say is you criticized me for saying China, and then you show me a bunch of clips from Russia. I mean, like, that could just be propaganda. That could be lies. You're saying, like, you're talking about, like, how humans lie and lie and lie. Why can't that be a lie?
Buddy, first of all, you said... No. You said, why do none of these people say anything? Like, are they just stupid? Blah, blah, blah. Well, the answer is obvious, right? The government is compartmentalized. For example, my father was in the military. There are things that to this day he can't tell me. To this day, he can't tell his own son. So you're not allowed to just go around saying things. In addition, there's a need-to-know basis. So when someone is an astronaut and they come out and say, no one has ever been to space, okay? That is a perfect example that someone couldn't hold it in anymore. Honestly, at the risk of dying to do it. Okay, yeah, you can say that they're lying. So so you're picking and choosing, right? Where it's like, we can believe in China or Russia. Well, never mind, neither one of those. So you agree we can't trust the Russian space agency then?
No, you're the one who said that humans lie and China is China.
Of course, humans lie. That's right.
Yeah, exactly. And I agree with that.
Okay. But what does he gain from going on the internet and saying that what he was part of is not actually going to space and that they can't go?
Well, I suppose potentially what you're trying to do and, get fame and,
what?
Be special.
You're just getting emotional, so now you're just trying to attack me more, right? Because you're like emotional.
I think, you
I'm trying to get fame. I'm trying to get fame. Dude, I had to get talked into doing YouTube. I turned it down multiple times. I didn't want to do it. I lost a 6-figure job because I was talking about this stuff on the internet. I decided to be famous, so I went and talked about a subject that's actively censored, got me kicked off of PayPal and Venmo. Third-party payment processing.
What was the area of that last employment of yours? Was it scientific?
It's just a sales representative.
Okay, so it wasn't like an engineer or anything.
That's totally not relevant. You never address the actual points.
Wow, you know what, dude? Like you know, you're talking about this and that and this and that, and then if I try and get a little information, it's not relevant. It's like,
No, you
dude,
just don't ever address
everything
my point. Like I always, I show you the respect to specifically address your point. When you ask a question or make a point, I respond specifically to it. But when I make a point,
no, not at all,
name one time I didn't.
dude. You know, like when you ask the question and I use an example to answer your question, you're saying, "Oh, that's completely irrelevant."
No, I said name one time I didn't answer or address your point. I do it every time.
Like, you're very indirect with your answers are very indirect. I wouldn't say
Right,
that
man.
they're. I mean,
people are
like,
going to
it's
get
good.
frustrated for me having you on here because it seems like you're not being like honest. Like you're not just having an honest conversation with me. Like let's start with some of the basics, okay?
You're trying to make me like a bad guy.
No,
Dude,
I bet that in the grand scheme of things, you're decently cool, and we could like have a beer or something, but not under the pretext of this conversation because you made up your own mind preemptively, and you've chosen to lash out against it. It's just an emotional decision.
No lashing out. No lashing out. How about this? I'm open to having my mind changed, and I'm not, you know, stuck with any particular belief. You know, here, prove me. Go ahead.
Okay. So for one, all the evidence ever has shown that we're in the center of the universe and that the Earth is not moving. We tried to measure the Earth with interferometry, which is lasers basically nowadays that intersect each other and they make really precise measurements. It's called interferometry. The lasers cross each other. They give you what's called an interference pattern. You can measure motion super precisely. When we tried to measure the Earth orbiting, it showed that the Earth was not moving. That's why Einstein had to come in and come up with the theory to say, oh, well, it just looks like we're not moving, and you'll never be able to detect or measure that we're moving. But I swear we are moving. You just can't tell. So all the measurements and evidence have always shown that the Earth's not moving. And your entire life, you've seen that the stars move in a circle around Polaris and just keep restarting.
So for those of us who are unfamiliar with the interferometer, can you tell us exactly how that trial worked? How they can show that the surface that we're standing on is moving compared to everything else?
Yeah. So this is specifically to try to detect that the Earth is going around the sun. But it's called Michelson-Morley. Yeah, it's called Michelson-Morley. It's also referred to as the most famous failed experiment ever. Okay, so it sent light in two different directions that were perpendicular to each other. One of the lights were moving with the Earth, and one of the lights were moving against the Earth, assuming that the Earth is moving around the sun. Based on where it's supposed to be moving, they shot one of the lights in the same direction as the Earth moving and the other one against it, which means that by the time that they recombine and come back to the receiver, they should be different because one of the light beams had to travel a further distance because it was going against the motion of the Earth, which means that it should create an interference pattern because one of them was behind the other, so they're not going to be received at the same time. The other one's going to come behind the other beam, which means that they'll intersect and create an interference pattern. But that isn't what was observed. They didn't see the interference pattern, and it changed all of physics because they had to say, oh, well, there has to be some explanation why the Earth is moving around the sun, but we just can't detect or measure it. And that's when Einstein came in and said, oh, well, actually, the apparatus that was measuring it, it contracted. But you can't tell that it contracted. It looks like it's the same length. But since the light had to travel further and you couldn't measure it, it's because actually, even though it did travel further, the apparatus contracted in the direction of motion. So you couldn't tell that the light traveled further. And he said, time slowed down and you just couldn't tell. So it made it look like the Earth wasn't moving. That's what happened. Theory of relativity.
Okay, that was a little bit kind of difficult to follow. I'm not gonna lie, without visuals or.
I'll show you a visual. I'll show you a visual right now.
Okay. I mean, this Michelson and Morley. You know, while you're looking, I guess Why? What is their opinion?
Their opinion was that this shows that the Earth is stationary. Let me find.
Okay, so they're like flat earthers.
No, we're talking about if the Earth is moving or not. And specifically, they didn't know the answer.
Right.
They're like, this
What I
shows
mean
that
is,
the
like,
Earth's.
do they?
It doesn't matter what they said. I'll show you what they said. It's right here. I already showed you what one of them said, but okay, here.
I mean,
so
like,
first of all, this is the
This
video. This is the video. Look, this is what was it.
Okay, I want to see it because I do want to see it. But right before you show it, after all of this, let's say into their late ages, into their older age, would they consider themselves? Would they assume, or would they say that it's a ball kind of thing, like flying or whatever, right? Or is it like the flat thing that you're kind of saying? Like, what was their stance at the end?
Well, this is what Albert Michelson says right here, because it's called Michelson-Morley. This is what he said. This conclusion directly contradicts the explanation, which presupposes that the Earth moves. Okay, and then this guy...
Okay, but they don't know that, like, they don't know if it's like flat or a ball. They're just kind of
this
talking about
is
the motion.
This is just about if it's moving right now. That's right. It's not even about if it's flat or not.
Okay.
Yeah. So here's the test. This is the expected result. If you assume that the Earth is moving around the sun, this is what you should have got. So you see how they're separated. So since they're separated, they give you what's called an interference pattern. They interfere with each other.
Right.
Right. Okay. So this is what should have happened if the Earth is moving, because one of the light beams is going the perpendicular direction. So then they recombine here. And now when they come back, since one of these had to travel further than the other one, it's basically behind. It has to catch up. It should take longer to get there. So it should intersect. See what I'm saying? So this is the expected result. When they did the test, though, this is what they actually got, where they were basically the same.
But there is a difference.
Well, the fact there is a difference is even worse. Okay. So... because this is what you would maybe see if there was an ether drift with a stationary Earth. So what Einstein said was, even though we measure a difference, that's just instrumental error. There actually is no difference. Now, this has actually been done like thousands of times since then, and there's always a difference, even with like thousands of times more precise tools now.
Right.
But they just say it's just an error because they don't have an explanation. But the point is that it should have looked like this. It's specifically based on 30 kilometers per second around the sun orbit.
Yeah.
So that's where they got this number. So it didn't work. It showed that the Earth's not moving. So then what they said was, well, it looked like it was the same because the apparatus, represented by the ruler here, it actually contracted to make them look like they're the same. So you see, now they're getting closer and closer together because you're contracting the distance. Okay, that's what Einstein said happened. But if you go and try to measure the ruler, it'll measure exactly the same. You won't be able to tell that it shrank. That's literally top tier science in 2023 to this day. The theory of relativity is that objects in motion contract in the direction of motion. So instead of accepting maybe the Earth's not moving, he literally said, oh, well, actually, this is just an error, that there's not a separation there. And then he said that the apparatus actually contracted. It's called length contraction. It actually contracted just the right amount to make it look like the Earth is stationary. Okay. And that's just the one of the tests, but it's the test that changed all of physics. It's like the most important one. And then if you look here, that's why Einstein said, I've come to the conclusion that no optical experiment can detect the motion of the Earth. Then he said, no terrestrial experiment can make the motion of the Earth in space perceptible. And he said, before I came up with the theory of relativity, it was like very difficult to reconcile this result. And there's Michelson himself telling you that the results directly contradicted the assumption that the Earth moves. This is Lorentz. He's the one that came up with the contraction idea. It's actually called Lorentz contraction. Einstein took his idea, right, and integrated into relativity to explain it away. And here he is saying, briefly, everything occurs as if the earth were at rest. He's the real genius that came up with the idea to save it, which is that it contracted, which is just a made-up story. It's not real. It's never been proven to this day.
The rest contraction is an ad hoc fallacy.
Yeah, correct. It's like they could think of no other way to explain away the results. Now, if you ask anybody that runs around defending the model about this, what they'll say, they'll regurgitate Wikipedia. And they'll say, no, Michelson Morley just disproved that there was an ether. But that's not what happened. What happened was it showed the Earth wasn't moving. Einstein had to come up with a theory. He said that in relation to the Earth moving around the sun, the apparatus contracted and makes you look like you're in the center and that the Earth's not moving. That's what he's talking about here. Arthur Eddington, one of Einstein's colleagues. Oh, well, there was just one alternative. The Earth's true velocity through space might happen to have been nil, or nothing, of course. So that's why this presentation is so important, because it covers the process of where we are now, where people think that the Earth is moving around the sun. They don't know what has actually happened. What happened was the evidence showed it's not. And they just made up some story that's never been proven to this day. Here's Lincoln Barnett, who literally wrote like an autobiography of Einstein. No physical experiment ever proved that the Earth's actually in motion. And it just goes on and on and on. So then that's why the CMB is important, because it's not just that back then, now it's getting even worse, and even more evidence is showing that the Earth's not moving and that it's in the center. But they are in a religion. So I'll stop talking so much, but I want to explain this to you, because this is what I was trying to get to you earlier. I don't blame you for believing this. I once believed it. Everyone on this channel once believed it. Everyone believed it, bro. Everyone was told, remember the planets, the Earth's a ball. Wouldn't I fall off the bottom? No gravity. What's that? It holds you to the ball, right? Okay, and the Earth's spinning, but we can't feel it. Well, it's just so big you can't feel it. Right? And you're moving around the sun in something called the solar system. Make this model of the solar system, blah, blah, blah. Okay? Like we all believed that, because why would we not? Why would someone lie about that? Why even question that? That's just something that we know. It's just a fact. Everyone here was in that same position. It requires looking into it and challenging your own belief, right? And then you find out it's actually not science. It's a religion. Okay, and here's Edwin Hubble himself explaining that. This is from the Hubble telescopes, named after this guy, one of the most famous astronomers ever. He said, such a condition would imply that we occupy a unique position in the universe, analogous, in a sense, to the ancient conception of a central Earth, as in the Earth is in the center of the universe. This hypothesis cannot be disproved, but it is unwelcome and would only be accepted as a last resort in order to save the phenomena. Therefore, we disregard this possibility. The unwelcome position of a favored location must be avoided at all costs. Such a favored position is intolerable. Therefore, in order to restore homogeneity and to escape the horror of a unique position, it must be compensated by spatial curvature. There seems to be no other escape. Edwin Hubble. So this is him saying, we can't disprove that the Earth is in the center. We can't disprove that it has a special and unique position. But that's a horrific idea. And we disregard it, even though it can't be disproven. And it's unwelcome and intolerable, the Earth being in a special position. Because if it's in the center, it's obviously special. So that's weird.
Okay, so
that's not science.
Well, okay. First, what I would say is, I see how much effort and work you put into all of this. It's pretty incredible. So you have a lot of passion and a lot of, you put a lot of effort into it. So I commend you for that. I think that's cool. Especially if you think if you honestly think that you're doing good for humanity. So I think that's cool. Props to you about that. I guess my two questions would be, what about the people who like go up, like high in like these like whatever rockets or whatever, they pay money or whatever, like Justin Bieber was gonna go up or something, like these billionaires, they take these trips and then they go up. And also like if you have like, let's say, followers to this channel and stuff, and like this movement is like gaining traction, and it's like people are like part of your agree with you, how come, you know what I mean, like the whole world would have, like NASA would have fallen or whatever, like the governments would have collapsed, like that's not happening, obviously.
Yeah, so I don't know if you know the history of this, but like flat earth and related subjects about the earth, it like exploded in 2015, 2016. It was like the third most Googled thing in the world, behind Hillary Clinton and Donald Trump, which was because that was right before the 2016 presidential election. It blew up on YouTube. It was like the number one watch thing. People were watching it for so long, the algorithms were promoting it, and it just blew up. It got so out of hand that YouTube official representative in court explained that they were going to roll out a new method of censoring flat earth, and they say flat earth specifically by name, and that they were going to deprioritize it in the algorithms, that they were going to promote the other videos saying flat earth was wrong, and that they were going to put disclaimers on all of the videos. So they basically announced that they would shadow ban and censor flat earth, and that they would promote the opposite ideas. So it died a lot. Like flat earth will never die, because once someone actually does the research and begins to look into it, they may not want to publicly say it because it's kind of intense and people like want to call you stupid and stuff. There's no going back though. So long story short, we're still growing. It's just that we've been censored.
Yeah, but it makes sense because like that's what it looks like if you don't know any better and you don't have access to like extreme technology from anyone's perspective. Of course, it would seem flat.
Yeah, well, you can go test it, but before we get into that, like your other question was about the people privately going to space, like basically billionaires and rich people or famous people going to space. What about them? Well, they claim that they basically take a huge parabolic flight and come back down, and just like there's something called a vomit comet. You can take a flight up in the air, and then when the plane starts coming down, you start free falling, so it feels like you're floating, like you're in zero G. It's called a vomit comet or a zero G flight. Basically, those private flights are just glorified zero G flights because they float for like 3 minutes, supposedly, and then they just come back down. And one of the ladies that went on, like the Blue Origin flight that went to space, supposedly, it doesn't actually go to space, right? Like it goes like allegedly 50, 60 miles up. Anyway, she said she was pissed because she said that's what I'm saying. She said she was on the flight. This lady said she was pissed because she was told and she thought that they were going to get to see the curvature of the earth. But when they were up there, you couldn't. This is a girl that was on the flight.
In an airplane.
What?
In an airplane, I see it.
No, bro. You don't. You think you see it, right? So, I mean, you may... I don't even know if you need to fly in a plane again and think about it, because a bunch of people say that, but once they go back and fly again, they're like, oh, wait, never mind. So you can ask any pilot in the world. They'll tell you, oh, it's completely flat from where we fly. According to the Globe's official math. Yeah, according to the Globe's official math, you don't see curvature from that height, bro.
But I do see it. And like,
it's like, no, you don't. You don't. You mean to show you a video I have with a pilot asking them?
Well, I mean, I'm saying like, if I took a video of outside the window while I'm in a plane, the video, which you can see on YouTube, people flying in planes, like it'll be like curved.
Okay, well, there's a couple parts of this. One is that there's a window, the way that the circular windows are made in a plane. If you're sitting even on the runway, you'll see the straight yellow lines and they'll curve down at the edge of the window because it's a circular oval window with a dip. So it imposes a little bit of curvature, like even on the runway. You'll see the yellow lines on the runway look like they're curving at the edge. But when you get high up in the sky, you can see that the horizon's flat in a plane. I know this because I've flown quite a bit.
I suppose this could be confirmed by pulling up like a sort of video of like, filming outside the window before it's up in the sky and then while it's up in the sky, I guess, right?
Yeah, I mean, I can show you pictures. I can show you pictures from the runway that you can see them curved on the ground.
But I mean, also like they've been making like, what are those called? The that you have in the classroom and stuff, like those maps, but it's like a ball map. It spins. Like
Globe?
They've been making those
It's
things.
just called a globe.
A globe, yeah. They've been making those things,
Yeah, okay. I mean, they made the first one in 1492, and it wasn't even remotely accurate. And supposedly they used it to navigate with Christopher Columbus, and he thought he was in India. I mean, they make globes. If you go buy one from the store, go read what it says on the bottom of it. It says not for educational purposes because it's not actually accurate. But you can make I can make a pizza model. I can make a triangle model. It doesn't matter what someone models, bro. You can go test the Earth. We went out and tested the Earth, bro. We have observations where the mountains should be hidden by miles of Earth curvature, but you can see the mountains. They should be miles behind a ball, but you can see the mountains. The reason there are so many flat earthers, but you don't really know many of them because they're censored, they don't say something publicly, is because we went out and tested the Earth. If the Earth is what they say, it has to curve.
There's not so many flat earthers.
In America alone, there's over like 40 million, according to a mainstream survey.
What is that, a mainstream survey?
Yeah, it's like a mainstream survey about science deniers. They went and did a survey across the United States, and 11% of people said the Earth was flat, and almost 20% of people said they don't think that the Earth goes around the sun. This is a mainstream article, which I don't even believe mainstream stuff. So,
well, I mean, people are getting dumber.
Okay, see, now you resorted back to like it's a default defense mechanism.
Well, I mean, do you disagree with that?
Yeah, because people blindly believe stuff like the air is going to kill you because the news said so.
People are getting dumber.
People are maybe getting dumber, but it's not the flat earthers that are dumb. The flat earthers weren't scared of the air. The flat earthers know that synthetic medicine actually kills you. Flat earthers know that all of our food is poison. Flat earthers homeschool their children, don't jab them as soon as they're born and basically destroy their immune system. The flat earthers are the ones that are not falling for the lies, the ones that are not stupid. I have a stack of books right there that the average globe earther couldn't even read. So,
I mean, I'm not.
There's no reason to generalize. I'm just saying, you said that as if the reason flat Earth is getting bigger is because people are getting dumber, and that's not true.
Well, I mean, like you can maybe meet me halfway where I can meet you halfway also, where I say like there's a lot of good reason to homeschool your kid, for example.
Yeah, that's why I'm saying it's all the truthers are the ones that are homeschooling their children and growing their own food and being self-sustainable and learning about electric culture and permaculture, and like it's the truthers, the sheep,
yeah, like
the ones that are dumb.
In human nature is to be like to, maybe not always be so honest, but yeah, I mean, from where I stand right now, I feel like you're kind of just denying human achievement for the last whatever it is, couple hundred years.
Not really, though. Like
achievements that you can look at.
Just name one thing.
I mean, like, whatever technologies that they use to go into space.
Okay.
And to survive.
That's the only thing you can bring up, dude. You don't think the government could have lied about going to space? They claimed they went to the moon in 1969 and that people haven't been outside of low Earth orbit since then, and that we destroyed the technology. We went to the moon, but we destroyed that technology, and it's a painful process to build it back again. You believe that?
Okay. So all the taxes that have gone to, from what NASA says, to achieve certain things, all the money that taxpayers have paid into that, and when they show on TV a certain achievement and they're like cheering and stuff, like they're just lied to. Those people, they're just dumb. or they're like lying about it. They're actors
Well,
or something.
it's not that they're dumb, because if you want to believe in it, you can. Like you watch the cartoons, they're admittedly cartoons, but people just assume it's real. They wouldn't lie about something like this. So they literally watch cartoons. Go look at any NASA live stream of anything. Go look at the Artemis mission where they claim they had just sent something out to the moon. Go watch it. It's all cartoons. They literally show cartoons the whole time, but people just assume it's real. So yeah, actually, speaking of, perfect time to plug this. Let me come over here to the full screen. I'll even share it for you guys.
What do you mean? There's so many pictures.
Oh, the pictures are admittedly composite and CGI images, which should be sketchy to you. This is the thing. This is the thing. It's a big conversation, man. It's going to require you to do research. But here you go. AuditNASA.com. This is the very reason that we just started this, is to see if you think it's real. I think it's not real. Well, we should be able to get together and see if that's the case. We want to ask them for actual evidence of their claims. That's what we want.
That's what I said. What I said that I like.
This is how much money they get, bro. Look at this. This is a live NASA funding tracker, accounting for inflation since it was founded. Almost $2 trillion.
Yeah, that's what I'm saying. It's like you're denying that.
They claimed that for $2 trillion, they went to the moon in 1969, but haven't been back in 5 decades, and that they destroyed the technology and can't rebuild it.
Well, I mean, you're talking about how humans can be liars. That could be just a lie for whatever reason, but they did it, so whatever. Didn't they do it like a few times or something?
No, they only landed on the moon one time. You're saying they may have lied about that, but not about the first time that they claimed they went in the 60s.
Well, I'm appealing to your answer.
I'm saying
they're lying.
No, we have caught them lying. We've caught them lying. You understand that? Have you ever looked into the videos? We've caught them lying with fakery on the ISS. Have you ever seen the videos? Because I can only stay on for a little bit longer, but have you ever seen the videos?
I've seen clips of they say that it's like they're using CGI, but yeah, maybe they are using CGI. Maybe it's really expensive for whatever reason to produce or whatever up there, and they just.
Dude, you're coping, bro. This is such a cope.
Hey,
coping so hard.
Can I ask a question at some point about the topic for tonight, about some stuff you said?
Yeah. Go ahead, since we're gonna get out of here soon. Good.
Okay. Yeah. So it was about the expansion thing. So you said that you do believe that the telescopes look at the sky. I know you've said you don't believe in expansion, and from what I understand, with the latter method, the whole reason they can say it's expanding is because they observe different bodies moving further apart. So then they think it's expanding. So I would assume you also think they observe that. So what do you think that is? Do you think they're just arbitrarily moving, but not actually kind of moving outward, or it's an illusion?
They don't actually see that. No, they don't see things moving away from each other. They claim that it takes so long that you won't see it. They claim that the evidence that the universe is expanding is that it redshifts. That's it.
So, okay, because I quickly looked it up, because I wasn't sure from the video, and I thought I saw something about observing the actual bodies moving apart. So what is the redshift? They see it's. I know I've heard you explain it, but it's it's like a kind of like a frame shift almost, or.
Well, you have the two spectrums. You have light as an entire spectrum. One spectrum you have ultraviolet or closer to blue. The other side you have red. So they're saying as something moves away from you, it gets further and further away. So it moves more and more towards the red spectrum of light because it's moving further away from you. So that light is physically moving away from you. Thus it redshifts, like the Doppler effect. They say it's like the Doppler effect, but then they say it's different, cosmological redshift. Anyway, when an ambulance comes by you, you hear the sounds, and it changes sound as it gets right in front of you, and then as it goes away from you, it changes again. Yeah. So they say that they're just looking at the spectrum of light, and they're saying, oh, it's moving towards the red end of the spectrum, so that must mean it's moving away from us. There's actually not a lot of verifiable evidence of that even on the Earth, but there's like many things that could explain it being towards the red end of the spectrum. That's what they claim.
So I'm looking. Go ahead.
So they need to. So I mean, how do they judge the distance? Because they need to have some sort of base measurement, right? So I mean, if it's just a slight change in color, how can you get any sort of indication from that?
Well, I mean, it's because they need the universe to be expanding in all directions, or it means the Earth's in the center, right? So like I was saying, they just built everything upon that presupposition over time, right? Like when they looked out, they expected to see red and blue shift all over the place, right? Like they just expected it to be chaotic and random and not care about the Earth at all. But they saw that everything was moving in a relation to the Earth. So they had to come up with an excuse.
Yep, but maybe I misunderstood it, but with the ladder method or whatever, the non-cosmic one, is a bunch of measurements built on each other. So wouldn't they have to have like some sort of specificity besides like a general idea that things are expanding? So I thought the specificity came from like observing bodies moving apart, but if it's just the redshift, then I'm not even sure how that would.
Well, okay. When you say moving apart, the first part of the ladder method is parallax. They claim to measure the movement of the stars relative to the background stars, and they use that to try to get distance. Now, if you look into parallax, that's a whole, it's misrepresented, right? It's not actually nearly as accurate as people claim. They don't really observe what they do. And then when they admit when it starts to get further away, they can't even measure it. So they claim that the first one is parallax. The second one is they look at these like pulsating stars, right? Which is called like Cepheid variables.
Yeah.
So they're stars that pulsate at a certain rate, and they say that that's directly related to the intrinsic brightness.
Yeah.
Right. So that they use that as something called a standard candle. So it's the relationship of luminosity. Does that make sense? Like that they use that as one of their standards. Yeah. It's basically they had to just piece everything together over time and assume it is expanding away and came up with distances that way. That's all that they did.
Yeah. Yeah, I guess the problem I would have then is with the base of that, the parallax, because at some point they have to claim they know some distance somewhere to compare it to some other distance. So do they just assume they know like one of the distances, or
yeah, so that's a great question. Yeah, so at one point they have to just like guess a size basically, right? Because like this is what they did with even the solar system. So they're like let me find another one of these.
Well, they must yeah. Okay, go ahead.
Well, they looked at Venus and they're like, okay, Venus must be the same size as the Earth. And then they were able to build the rest of the solar system off of that. So you need some point to start, like you're saying. So what their first distance claim was, I couldn't tell you for a star. I don't know. Right. But seemingly they just look at the brightness of stars and then they see them moving supposedly. Right. And they just had to throw something out there. So they looked at like the diameter of light, assumed that it's in a vacuum, right? And then they did the math about how long it would take the light to get there. And then they assumed a size based on how far the light would travel. It's insane. I couldn't even tell you how they came up with the first.
Yeah, it's built on assumptions. Okay, yeah. So as far as like the red shift with what like in your personal, like what you believe, what's one or two explanations you think could be the redshift that's observed?
Yeah, so one could just be attenuation, meaning like light. Like when we view light in the sky, it attenuates as. I don't think light travels, so it's hard to talk about light, but just so everyone understands it, as the light moves towards us, quote unquote, as we perceive the light between us and wherever it's coming from, it attenuates in the medium. Just like if I shoot a flashlight in water, it's going to attenuate way more than if I shoot it in the air. Because it gets absorbed by the medium. If this happens, this can make it move towards the red end of the spectrum. They don't actually look out and just see the color red everywhere, right? It's just that they say it's moving closer towards the red end. It's closer to the red end. So it could just be attenuation. It could also be plasma. This can be proven on the Earth in a lab. So like if there's a medium in space that is plasma-like, or even it just has a bunch of plasma in it, then light as it moves through plasma redshifts. So if there's plasma in space, it would cause redshifting as you see the light through the plasma. So you would have an electric relationship within the plasma. This can be proven in a lab on the Earth. And then also there's magnetic redshift as well. You can get red and blue shift just because of the phenomena of magnetism, which seemingly everything is electromagnetic. Now this actually makes sense because we have blue shifting going on as well. Like the Andromeda galaxy, as they call it, is blue shifting, which means it would be moving towards us, and they just make up a bunch of excuses as to why.
Okay.
Man.
Yeah. Well,
yeah.
Sorry.
I'm just watching all these clips that you have playing, and to me, like, it doesn't make sense. It's like, wouldn't it make sense that they have to, like, for example, wear seatbelts in a sense and not hurt themselves, or like maybe they're filming something here on Earth, and they're using it for some reason, and you're just thinking it's like supposed to be actual footage when it's just like a commercial or something.
No, they claim it's actual footage.
So
they say this is a live stream from space. Yeah.
Oh, so this is all their stuff.
Yeah. Oh, yeah. Yeah.
But it's like, okay, so wouldn't it make sense for like safety or whatever that they wear like harnesses and stuff to, not get hurt or whatever?
They specifically say they don't wear harnesses. Look, dude, watch this guy right here. This is so funny. We actually talked to an astronaut for the Level With Me film, and we asked her. Look, he grabs the string right there. It's so funny. We asked, so why do we've caught them with wires and harnesses on the ISS. Do you know why they have to wear wires and harnesses on the ISS? Is it to keep them in screen because it's hard when you're floating in space or something? And she's like, "Oh, I'm not sure. I'm not sure about that. I don't know anything about that." So, but the official story is that they don't use wires or harnesses. They just actually came out and publicly addressed the accusation and said that that's never happened.
Well, that makes sense, right? Like you're trying to. It's like they're not always doing like interviews or whatever, and for the moment they have to be, stationary, so they have to like gear up or whatever.
Well, we came up with that excuse for them to see if they would take the bait and admit they use harnesses, but she was smart enough to know not to take the bait, so she just laughed it off. But NASA just admitted or just addressed this publicly because of my friend Justin Harvey calling them out, and they said no one on the ISS has ever used wires and harnesses. So they made the claim now that they don't use it. So just wait till Audit NASA gets finished because we're about to completely expose them because they are lying. This footage is filmed on the Earth in a studio. This is fake.
Yeah, I'm interested to see how that comes out. Audit NASA. I mean, but I mean, I was looking up some stuff right now for Flat Earth just as you're talking, and I quickly read that they don't believe also that the sun is like, combusting. How does that work? So it's like a light?
Yeah,
that
I mean,
makes no sense.
Truth is, we actually just don't make claims about what the sun is. It could be all kinds of things. It's seemingly electromagnetic in nature. Just be electromagnetic focal point. It could be all kinds of things. It could be combusting even. It doesn't... We don't make claims about what the sun is.
Online, it says that it's like a 2D disc. It's not even like a 3D ball.
People differ.
I've heard many claims that, the general claim is it's a small local sun, right?
Yeah. As to what it is or how it works, like we don't know. But yeah, it's
right. So you're saying
much more local.
Close. The sun is close to us.
Yeah, that's why it's warmer when it's directly overhead than when it moves away. That's what would happen if the sun was close, not if it was 93 million miles away.
Yeah, but if it was close, we'd all burn.
No.
No, it was smaller.
Smaller, yeah.
Yeah, because I mean, no one's ever stuck a thermometer in the sun, right? So you could.
But I can
that's
feel
just
the heat on my face, and I can look up and see that it's huge.
That's proof that it's closer. The
And
fact
far.
that you feel the heat and that it changes so drastically as it moves through the sky is evidence that it's closer to us.
Well, it could be like an angle thing.
What?
I don't know, like on a certain angle, maybe it passes the atmosphere easier or something.
Okay. Yeah. So the sun seemingly is low. We have crepuscular rays, right? We have the rays diverging away. So we feel the temperature difference. So what flat earthers actually say is that the sun is just smaller and more local. Admittedly, in the mainstream science of heliocentrism, they don't know what the sun is. There's something called helioseismology where they're trying to figure out what's going on, and they say they look at spectral lines of the sun and think it's made of hydrogen. They claim they think it's like a nuclear reactor, but a lot of their stuff isn't working out together. They don't know if it's like black body radiation, what kind of black body it is, what's the charges of it, trying to change the charge to make it work with mercury, all that stuff. So they don't know what it is, even though they're making up stories. Flat earthers are much different. We don't want to make up stories that we have no evidence for. So what we have evidence for is that the sun and the moon are the same size in the sky, and that there's a light for the day and a light for the night. The globe model claims it's just a coincidence that they look like they're the same size, and actually the sun is 400 times bigger. Just coincidentally, by random chance, it's also exactly 400 times further away, so they look like they're the same size. That's just ridiculous.
Well, I mean, it could be possible. I know it's like a hard chance, but hey, life is a hard chance that we're all here and we are here. So, but I mean,
because if you have intention, some type of creative force, then of course you can have anything happen. But they actually specifically try to explain it away without that. They say it's all random. So that's a them problem.
So do you have some sort of idea about how we all we're all born on this planet then, or something like that? Like, what is your
thought? I would drop the T off the planet. It's a plane, but yeah, we were created. There's some type of creative force that made us with intention. There's no other way. So I personally, I'm not scared of that. That's why I don't have to make up stories about the Earth.
Okay, but you seem super adamant about your point of view. How did you get into all of this?
I heard a rapper say it and thought it was incredibly stupid, so I just looked into it to prove how stupid it was.
And when was this?
2016 Earth Day.
Okay, and a rapper. So you're listening to a rapper?
I was listening to B.O.B. He said that the Earth was flat, and I'm like, what does that even mean? I'm like, we have pictures of the Earth from space. So I just went to look into it real fast and show how stupid flat Earth was. Then I found out that the picture from space that was on my iPhone actually wasn't a picture. It was admittedly a cartoon. It was an animation. And I'm like, what? It's like the 21st century. Why did we not have just real pictures of Earth? Why are they cartoons? And then I found out that
it's from a rapper.
No, I specifically said I didn't do that. I heard him say it, so I just looked into it to disprove it. Then I went to nasa.gov to get pictures of the Earth from space, and the most recent blue marble picture was admittedly an animation. So then I'm like, wait a minute, where's the real pictures? And they said that the last real picture of Earth from space was from 1972 during the Apollo missions, and I already knew the moon landings were fake. So for me, I'm like, wait a minute. The only real picture you have is from the Apollo missions, which I've already done deep research into and know they faked that. So I'm like, no way there's something more to this than I thought. So I just looked into Flat Earth to try to debunk it for a long time and did lots of research. And I found out you can't debunk it. So then I went out on the Earth to test it myself. And then I was forced to accept that the Earth is in fact a plane. It is not a ball. with a radius of 3,000 miles. There's not a chance.
So why doesn't NASA or NASA employees do these things that convinced you?
Well, like I said, some of them do. So, like I literally know
But if they
one.
did, but if they did, wouldn't they come out and say it?
They do.
And wouldn't that destroy NASA?
No, they just censor them and then discredit them.
All of them?
Well, there's not a ton of them because the people that have come out, they get all kinds of death threats. I get death threats. Imagine a NASA employee. You get death threats. They'll never be hired anywhere else again. They get censored.
Wouldn't it be like your peers if you're working at NASA? And like, wouldn't you tell your peers, and wouldn't they, even if they didn't believe you, wouldn't they try what you tried, your peers, and then like a domino effect, all of them?
I don't know what they do, bro. I don't know if they have to sign NDAs. Like, I don't know. I don't work there. I'm going to have a NASA employee on soon, and we're going to talk to them. We're about to talk to tons of NASA employees with Odd in NASA. One of them came out and said, actually, one of their higher ups is the one that told them that the Earth was flat. That's how she found out. A former NASA employee. Yeah. Verifiably a former NASA employee.
When are you going to do this interview?
I don't know. I have to link up a date with him. With the guy. With the girl, I'll have to reach out to her. I don't know. But,
yeah, you should definitely do that. I'd be interested.
Yeah, I'll have to email him back.
You've piqued my curiosity.
Well, that's good. You should definitely not just believe it in one day, right? So you have to just
it's
research.
Insane, though.
I get it, bro. We all thought it was insane, bro. So I don't in any way hold that against you.
Like, but, even my experience, like every day, it's like I don't get it.
Well, you think that right now, but you go back and look into your experiences. So I do have to get out of here because it's 1:15 in the morning for me. But I'll give you one experience to think about. Okay, I don't know if you live close to an ocean, but if you do, that's the best place to go. Just go look at the ocean and ask yourself if it's flat or not. But when you see the sunset, okay, the flat Earth says that the sun is local. It moves away from you, which is why it cools down. And then it gets so far away, you can't see it anymore. The sun is moving. So Flat Earth says the reason you see the sun move in the sky is because it's moving in the sky.
Yeah,
the globe Earth model. Think about this, dude. The globe Earth model says that during a sunset, the sun's not moving. It just looks like that. It's just an illusion. And that during a sunset, you're actually falling backwards. You're falling backwards, right. And that's what's making the sun look like it's going down and setting.
Yeah, and it looks like that. But if it was flat, then I would be able to see like the sun all the time, even when it's like far.
No, like if I shine a flashlight on a road and I started walking away from, do you think you'd be able to see it forever?
Well, if it was big enough, yeah.
No, you wouldn't, bro, because there's something called attenuation of light. Light only goes so far, it gets absorbed by the medium. Also, you can't just see forever anyway. You have a limit to how far you can see. You're not a Superman, bro. You can't see forever. I don't know why people think that.
It's less about what I'm capable of and more about what the sun is capable of.
It's capable of a lot. We can see it for many, many miles. Eventually, it gets so far away that we can't see it.
Like, I would be able to see it because the sun is just that bright.
No, I'm about to show you right now. I'll show you the sun disappearing into the atmosphere. Not behind the Earth, not behind the horizon, into the atmosphere. There's no sphere, but you get it. So I'm about to show you that the sun can disappear.
Atmosphere? Shouldn't you use a different word?
Yeah, but I was saying it to you, so you knew what I was saying. If I had just said Atmos, I don't know if you would even know what I was saying.
Do you have a different word that you would use?
I say the Atmos, which means air. So I'm about to show you. Yeah, I'm going to show you this video real fast, and then I'm actually going to get out of here, but I'm also going to show the stream. Okay, watch this video. This is one of the prettiest videos I've ever seen in my life, but this is a sunset, obviously, over water. Now watch what happens to the sun. Now, the globe model claims that the sun disappears behind the curve of the Earth. So the Earth is curving, even though it looks flat, and it's blocking the sun right now. That's why. Now, the flat Earth says that the sun moves away, and eventually it disappears into the atmosphere because it gets so far away from you, and you're looking through the atmosphere. You can only see so far. It's going to disappear into the vanishing point. Now, the globe claims that the Earth is curving and blocking the sun. So let's watch and see what happens here.
I mean, I'm watching. I'm still watching up. But while we're watching, I just want to say, because you say you have to get out of here, but dude, I have like so many more questions right now.
Yeah, of course you should. Yeah, I mean, I talk about a lot of them on here.
Like, for example, when I see like a boat going further away, it's like going down. But also like something I saw a long time ago that I just remember right now, but see, like, look, even in the video,
look at this, look at this, look at this.
Going down. Yeah,
but watch this. Yeah, because as things go further away from you, they drop down, bro.
Yeah, but dude, look how huge it is.
Watch what? Yeah, because it's close to you. But watch it.
Close to me.
Yeah, if you put a solar filter on, it doesn't really change size. But watch this. Where's it going? You see the water? That's the horizon. Wait, where's the sun going?
Well, I mean,
it just
like,
disappeared into the air.
Well, it could be like what's that called? Like a mirage type of deal with the refraction or whatever of the light.
What? The sun just disappeared into the air, bro. It just disappeared into the air. It didn't go down. It disappears up.
Bro,
which shows that what this shows is that perspective and the Atmos can make things disappear from the bottom up, and that the sun disappears into the vanishing point, not behind a horizon.
It's going down. You can see the top only.
Okay. Do you not know that if
see the space in between the light and the water is what he's
exactly
saying.
Exactly.
Okay, but that could be like, I'm basically ignoring that because like that could be like, you know, the heat or whatever, the water, the steam, you know what I mean, whatever.
So you agree that the sun can disappear just because of the Atmos, not only because it goes behind the curve of an Earth.
Well, I mean, like it can look like that, the light hitting
That's
the
what we're
camera.
talking about, bro.
Like
Did you know that you do realize, right? If say I hold a flashlight up above my head, if I start walking back away from you, you realize that you're gonna see it drop down as I walk away, even though it's at the same height. I'm holding it at the same height above my head. It's gonna look like it's going down. You know that, right? Obviously.
I mean, you're dude. Anyway, this is kind of confusing me, but like I know you have to go. I just wanted to say one more thing. I saw this video a while back, and maybe this is the right place to bring it up. It was like the moon, and there was like a blip on the moon or whatever. Like there was like a line going down the moon or something. It was like they were saying like the moon is like a video or something. The moon is like a wave or something.
Yeah, it's called a lunar wave.
Okay,
yeah,
what is
a wave? A wave goes across the moon.
Yeah, so you're saying that the moon and the sun, they're fake.
No, what? No, they're just lights in the sky, dude. But the point is, and like I'll get the moon looks like it's solid. Look, you see this? You see this picture right here? You see how the lights look like they're going down? They're all the same height, though. You see, these are all the same height, but it looks like it's going down. That's exactly what the sun does. It's because
but it never goes. You could always see them, though. It's always above the horizon.
Well, yeah, but what if they went infinitely? Eventually, you wouldn't see them anymore.
So you're saying
that the sun was also above the horizon in that video when it disappeared.
You see how you can only see them so far. Eventually, you're not going to be able to see them.
Yeah, but they don't go like it doesn't fall off of. It doesn't fall over. You're always going to see it.
No, you're not always going to see it. Eventually, you're not going to see it. It just keeps going down. And then what the horizon actually is, it's like the limit to your perspective. It's called a vanishing point. And it changes. Yeah, right. It goes up and down. The horizon goes up and down, up and down. It's not a real physical place. It's just an optical. Right. The Earth being so big doesn't make the horizon... That doesn't make the horizon go up and down.
But it could be like the limitation of your physiology. Just because let's call it a limitation of physiology. that could just be the limitation of your physiology, and not, that's just your limit, and still it's going over, right? If you could see further than that, you'd probably see it going over.
I don't know where you guys went on the screen. All right, that's a sign that I'm supposed to get out of here. But yeah, you do have a lot of questions. I could talk to you about a lot of them. You can go to 24/7 Flat Earth Discord, or you can go to Earth Awakenings on Discord, and you can ask lots of questions, lots of basic questions. You might want to go to 24/7 to ask your basic questions, but yeah. You can go to my Telegram. You can go watch the Skull and Globers episodes. You can go watch some of my debates. I debate people all the time. You can actually go, I think I have a debate playlist that you can watch, and that's where a bunch of the basic questions are asked and addressed.
But do you debate like legit people, or do you just debate people like me who don't even know?
I debate people that know all about it. You can also go to my channel and go to In the Field. I talked to a PhD astronomer a while back. I talked to Robert Sungenis as a PhD, made the movie The Principle. I talked to another physicist, relatively speaking, 2 weeks ago, I think, a PhD in physics. I literally will debate anyone, bro. Yeah. They can't debate it. It's just, I'm going easy on you, bro. To be honest, like, I'm not like bringing out like the big guns, like line of sight microwave transmission over up to 300 gigahertz with only 1 millimeter of beam divergence shot 250 miles when the Earth curvature should have actually blocked it at less than 20 miles. So the microwave line of sight horizontal propagation debunks the globe,
Whoa.
Like, or radio transmissions, I can go through that too. So yeah, I mean, it's just I don't just drop the smoke on people. Yeah,
I'm not a pro. I just kind of, couldn't believe it, and I still kind of don't really, like, I don't know. I think it's crazy. Like, it just sounds all insane. I don't know. Like, everything around me is like says one way, and then I hear like, there's like a small group of people who are like just everyone wants to go against the narrative, so everyone wants to like fight or whatever.
Well, we're gonna wrap it up, bro. But like, it got way more chill. Like, it's way easier to talk to you now. Like, I'm enjoying talking to you now. I've been on for a long time, but I get it. Like, you just have to just keep looking into it, bro. Like, no one heard about this and then they were just like, boom. You did actually kind of get a crash course. The fact that you're first time you're even thinking about it, you're like talking to me, being able to ask all your questions is better than what I had to do. I had to go look up each different question I had myself, but yeah, you should just keep looking into it. What you should do is just maybe tomorrow, if you're going outside, whatever you're doing, just like look around and think about it, because you've never really thought about it. Yeah, like when you think about it, you're like, if you say you see the moon during the day, you're like, that's interesting. I see the moon in the day, the sun in the day. They're like the same size. I see them moving throughout the day. I don't feel like I'm moving. I see the horizon is horizontal. That's why it's called horizon. Like, when you start to think of everything, you're like, well, everything I experience does show me that the Earth is stationary and flat, and the globe claims, it's because it's so big. I get it, but like, you have to still just take it in. Most people have never taken it in. They don't actually think about it, and that doesn't prove that the Earth's flat, because the globe has an explanation that the Earth's so big you just can't tell. But okay, but the default is that it's flat and stationary.
Well, I always try to keep an open mind about everything. I always try and keep an open mind about everything, and this is not the first time I've come across this flat Earth stuff. That's why today I was kind of, I kind of went in on it because I just wanted to see. But yeah, I mean, like, with this audit NASA thing, like, when is that going to happen, and what are you guys trying to do? Like,
yeah, so we've already started it, and we're putting together a team of a lot of people, like a professional team of people. But we're just going to be auditing NASA. We're going to be calling them, emailing them, talking with them in person, FOIA requesting them, hitting them with legal requests.
Oh, it's not. I thought it was like the court is going to go look at them or whatever.
Well, we are going to also bring stuff to courts, but that's tough, bro. To go against the federal government's not easy. You have to catch them red-handed, and then they'll probably just strike it down.
From what it seems like, you guys, at least according to you guys, it seems like you have like a solid, and you're catching them on all this fraud. That's, isn't that weird to you that even though you have all these, super, impenetrable defenses to your arguments and you catching them on all this stuff, but it doesn't matter. Like, isn't that kind of sketchy to you?
No, it's like, that's what censorship does, man. So we have to fight through the censorship until we get the word out there. It basically already is. I mean, on TikTok, it has 2 billion searches, flat earth. I mean, it's just a matter of time. Most people haven't seen those videos. So that's why we're making a documentary. My buddy just called the ISS out in court, got 10 million views in a couple days on different platforms. City council meeting, wore a suit, called out the ISS in Florida, in the county that they send stuff to space allegedly. And anyway, so we're doing a lot. We're doing everything we can, man. If you're asking, like, isn't it it's frustrating if you're saying, like, it must not be true because you have all these different answers, but it's not like everyone knows about it. They will eventually, and it's growing pretty insane. We have like incredibly big people talking about it now, so it's just a matter of time, honestly. I mean, I'm chilling. I kind of like am enjoying that it's not completely out yet, because you have to deal with, everybody. So,
I mean,
just look into it, bro.
I don't want to be rude, but that's where I would have said the people like to feel special thing. I'm not going to say it because I don't want to, be rude or whatever. But you know what? I know you said you have to go, so I appreciate your effort and the time and all the stuff that you're doing. Like, whether it is or not, like, you put in a lot of work, and I think that's cool. I'm gonna let you go to bed, bro. And I subbed to your channel, so I'm gonna do some looking into it and stuff, and maybe I'll call again.
Cool, yeah, man. You maybe a good place to start if you're gonna watch something on the channel is go watch the conversation I had with Robert Sungenis. So there's a video called In the Field, Robert Sungenis, a little back. And it's an interview I had with this guy, PhD. You might want to watch the documentary, The Principle, too. But that starts you off where you find out, oh, wow, the Earth may be in the center, and then you can go from there. But do whatever you want to do, okay, and you can call in the future.
Okay, brother. I appreciate it. Thanks, man.
Yeah. Yep. Have a good night, brother.
Appreciate it, bro.
Yep, later.
All right, cheers.
All right, this was a crazy long stream. I gotta get out of here. Sorry it was so long. I don't know where you guys are. Here you go. All right, sorry the stream was so freaking long. My goodness. One flat earther at a time, I guess. Well, the idea is that other people can watch the stream. All right, you guys were like, he's hopeless, he's not listening, and you never know. So all right, thank you guys for kicking it. I'm getting out of here. It's 1:30 in the morning. Go to auditnasa.com if you want to support. Also go to trueearther.com, linked in the description. The summit is this Friday and Saturday, so we're like in a matter of days the summit is happening. Very much appreciated. Thank you. So trueearther.com, you definitely want to check it out. I'll be pushing the summit trailer maybe tomorrow. We'll set up a premiere for tomorrow morning. All right, and shout out to that guy. Once it all chilled out, it was cool, good convo. How long has the stream been? 3.5 hours. Jeez Louise. All right. I love you guys. Seek and speak truth unequivocally. If you want to support the channel. Oh, I don't want to miss the super chats. Let me read them. YouTube finally added a function where you can catch all the super chats, so we're good now. Cash out, homie. So, thank you, Lewis, with one for the super chat. Retro Ricer Game, is it me or do Globers seem to be very game asking for a friend? Hit or miss. Louise with one eye. Accepting Earth being stationary doesn't happen overnight, nor with hours of research being deeply indoctrinated. It takes something more powerful that needs to build up from within. Yeah, I don't necessarily disagree. I think it's maybe a combination. I think people start to come across the information and take it more seriously when it's their time to wake up. Thank you for the $10 super chat. Anson Howard, thank you for the $10 super sticker. Much love. I told you to cash out while you were ahead. Not sure what you're talking about, but thank you for the super chat. Your super chat. Another $2 super chat. Glad you are not well known. Not sure what that means, Patrick, but thank you. Rich Leone, this is great. Please invite he back for Glober Comedy Hour. Good to see you, Austin. Love when you were yelling at the mic. Rich, thank you for the $5 super chat. He ended up being cool. D369, thank you for the $10 super chat, brother. Super fluidity of naughtiness. Thank Yah that you got tenacity and determination to stick with folks trying to wear you out with obfuscations. When you make them stay on course, they fell. Yeah. You get used to it. I thank you for the $5 super chat. Miguel P, thank you for the $5 super chat, brother. Much love. All right, cool. Let me check on the Rokfin. Shout out to the legends in Rokfin. Level-headed, thank you for the $10 tip. And Joy Parlek, thank you for the $10 tip on Rokfin. Much love. All right, cool. I think we're good. If you want to support the stream, you can go to Witsit.live. If you want to avoid the grabblers taking some of it, you can also go on Rokfin. You can also go to the links in the description. $WitsitGetsIt on Cash App. I love you guys. Seek and speak truth unequivocally. This has been Relatively Seeking episode 8. We talked about the Hubble crisis, one of the biggest crises in cosmology. So just pull that ammo out against people, like, well, have you heard of the Hubble tension? And then just explain that when they try to measure the supposed expansion of the universe, the numbers don't match with the cosmic microwave background measurements of expansion, and then the latter method, which is like parallax and brightness of stars and all this other stuff that astronomy's built upon for years and years and years. The data doesn't match. It's a serious problem. They have an issue that they cannot solve. In fact, it refutes their model, but they would say nothing ever refutes their model because it's a religion. I love you guys. Seek and speak truth unequivocally. The weak find contentment in the consensus of ignorance. So don't worry about what other people think. If you're new to this subject, you're just looking into it, just get rid of the fear of not being accepted by the majority. That always happens for a matter of time. But informed people don't care what ignorant people think, and strong people don't care what weak people think. When they revile you for his name's sake or for the truth's sake, just rejoice. They did it to all the prophets and all the truth speakers before you. Just kind of know that what's popular is not true, and what's true is rarely popular. I'll catch up with you guys Wednesday for the next Skull and Globers. Peace out. Much love.
Relatively speaking, first day after the weekend. Relatively speaking, first day after the weekend. Mickelson Morley, it showed that the earth they don't move, huh? What they do, shorten the length of the ruler. Hey, that's just how they fooled y'all. Tune in Wednesdays, bet that we gon' school y'all. Mickelson Morley, it showed no displacement. Nicholson, Gale, Pearson, it measured rotation. Let's break it down in layman. That means the Earth is stationed. No planets and spaceships, they're all animations. Relatively speaking, first day after the weekend. Relatively speaking, first day after the weekend.